Welcome back to Sleep Nova. Sit back, relax, and don't forget to comment where you're watching from down below. It's amazing seeing people all around the world supporting my small channel. Now, enjoy the show. We speak of everything, yet we hardly grasp its magnitude. Everything is the totality of existence, the stars and galaxies, time and space, energy and matter, life and mind. It is all that is, all that ever was, all that ever will be. In its embrace are the quiet dust under our feet and the shining furnaces of distant suns, the hum of a thought and the roar of a supernova. To contemplate everything at once is to stand at the shore of an infinite ocean, awed and humbled. Even our most fleeting reflection on the cosmos can send a shiver down the spine, as if some deep part of us remembers that we are a part of this grand tapestry, woven into its very fabric. On a clear night, under a vault of stars, we gaze upward and attempt to fathom our place in a vastness without obvious bounds. We see pinpoints of light scattered across a canvas of darkness, each a sun, perhaps with its own planets and stories. We feel small, yet we are connected to all of it. The iron in our blood, the calcium in our bones, the carbon in our DNA, these were forged in the hearts of ancient stars. We are children of the cosmos, built of its matter, energized by its light, and guided by our curiosity to understand it. Through science and imagination, we stretch our minds toward the edges of the universe, seeking to grasp how all of this came to be. From time immemorial, we have gazed at the heavens and spun stories about our place among the stars. Today, our tools are telescopes and equations, but the sense of wonder remains as profound as ever. In this journey, we will blend science and poetry, fact and metaphor, as we explore the cosmos on every scale. We will touch on cosmology and physics, astronomy and mathematics, philosophy and human curiosity, all the lenses through which we seek understanding. Together, let us venture to the very beginning of time and back, and to the farthest reaches of space, in pursuit of the story of everything. Our journey begins at the very beginning, at the origin of everything we know, in the primordial darkness, before a single star had ever shone. All that would become the universe was cradled in a point smaller than an atom. It is nearly impossible to imagine. A seed of unimaginable density and heat. A single point that held the potential for galaxies, for life, for every atom and every moment in time. And then, in an instant about 13.8 billion years ago, that seed exploded into growth. There was a flash of pure creation, a moment we call the Big Bang. Time and space themselves were born in that moment. What had been nowhere became everywhere. What had been nothing became everything. The newborn universe expanded with incomprehensible fury. In a tiny fraction of a second, it swelled from microscopic to cosmic scales. This extraordinary growth spurt, known as cosmic inflation, stretched space like a balloon inflating at faster than light speed. Distances between points grew by an enormous factor, smoothing out any clumps or curves. Inflation explains why the universe today is so uniform and flat on large scales. It was as if any initial wrinkles in space were ironed out by this tremendous expansion. A smooth, seething fireball emerged from that initial burst. Tiny quantum fluctuations, random little flickers of density in that early vacuum, were blown up by inflation into slight variations in the otherwise even spread of matter. These faint imprints would one day guide the formation of galaxies, but for the moment, the infant universe was a hot, dense soup of energy. As inflation settled, the energy driving it transformed into matter and light. The universe was 1 second old. In that first second, space was filled with an intense, blinding glow, radiation so hot that it would have vaporized anything, though as yet, there was nothing but fundamental particles. Matter and energy were not yet distinct. They flowed together in a plasma, a fluid of raw creation. Protons and neutrons jostled in temperatures of billions of degrees. In the minutes that followed, the entire universe itself became a nuclear reactor. These building blocks began to combine in countless tiny nuclear forges across the young cosmos. Protons fused with protons, neutrons linked with protons. By 5 minutes of cosmic time, the first atomic nuclei had formed. The simplest elements came into being: hydrogen, the lightest of all, and helium, its slightly heavier kin. A trace of lithium also appeared. In that brief early epoch of nucleosynthesis, the universe forged the basic chemical foundation it would use to build everything else. About 3/4 became hydrogen and 1/4 helium by mass, an elemental newborn universe. Still, no atoms as we know them could yet exist. The universe was far too hot for electrons to settle into orbits around nuclei. Instead, electrons careened freely through the dense plasma, scattering light incessantly. Photons, the particles of light, were trapped in a cosmic fog, bouncing from one free electron to another. Space glowed as bright as the interior of a star, but no light could travel far. The universe was opaque, a brilliant radiance suffused within a swirling, glowing mist. As seconds turned to minutes, minutes to hours, and hours to years, the young cosmos continued to swell and cool. Hundreds of thousands of years passed. Expansion took its toll on the fireball, diluting and cooling it steadily. At around 380,000 years after the Big Bang, a critical threshold was crossed. The temperature fell enough that electrons could finally be captured by nuclei. Protons clutched electrons to form hydrogen atoms. Helium nuclei gathered electrons to become helium gas. This transition is called recombination, though it was the first time such combination had occurred. With electrons now bound into atoms, the fog lifted. The once captive light was free at last. In every direction, a brilliant afterglow burst forth and raced away through space. The universe that had been opaque became transparent. That first light still surrounds us today. It has cooled to a gentle microwave glow that bathes the entire sky. The cosmic microwave background, the oldest light we can see. Back then, it was a searing, orange-white illumination everywhere. As space expanded and cooled, that light's wavelength stretched beyond red, through infrared, and into the microwave part of the spectrum we detect today. Discovered as a faint hiss in radio antennas, this afterglow is a whisper from the time the universe took its first breath as a transparent cosmos. The universe then entered a deep, dark age. With the primal light released and streaming onward, space itself went dark. There were not yet any new sources of light. The primordial gases, mostly hydrogen and helium, now drifted through expanding space like a vast, invisible fog. Gravity, the great sculptor, began to gently tug on the ever-so-slight variations in density left by inflation. Regions that were just a bit denser than average exerted a stronger pull, drawing in matter from their surroundings. Invisible threads of gravity started weaving patterns in the darkness. Over tens of millions of years, those threads pulled gas into clumps. The silent clouds grew denser and tighter until, at last, there was fire again. Perhaps 100 million years after the Big Bang, the first stars were born. Deep in massive collapsing clouds of hydrogen and helium, the pressure and heat ignited nuclear fusion. Starlight pierced the darkness. These first stars were giants, short-lived behemoths burning hot and blue, forging heavier elements in their cores as they shone. They lived for only a few million years before dying in titanic supernova explosions, seeding the surrounding space with the new elements they had cooked up: carbon, oxygen, nitrogen, iron. Ingredients that one day would be essential for planets and life. The death of each star sent enrichment into space, and out of the ashes, new generations of stars would eventually form. Their brilliant ultraviolet light also gradually burned off the primordial hydrogen fog in intergalactic space, reionizing the cosmos and allowing light to travel freely everywhere. With the birth of stars, the cosmos had begun to light up structure by structure, ending the long night of the Dark Ages. The cosmic dawn gave way to a growing day as the first stars and nascent galaxies illuminated the heavens. As stars gathered, they formed the first proto-galaxies, small galactic building blocks that later merged into larger ones. Gravity continued its tireless work on grander scales. Stars bound themselves into galaxies, and galaxies gravitated into clusters. Over hundreds of millions, and then billions of years, a vast cosmic web took shape. Galaxies pulled on one another along filaments of invisible matter, collecting into chains and sheets. Imagine a spider's web made not of silk but of galaxies, strung along invisible filaments, with enormous voids of near-empty space in between. Astronomers mapping millions of galaxies, for instance in the Sloan Digital Sky Survey, have unveiled this vast cosmic web in detail, huge filaments like the Sloan Great Wall stretching across hundreds of millions of light-years, and immense voids nearly empty of galaxies. It serves as the large-scale structure of the universe. Galaxies grouped like sparkling dew on cosmic threads, clusters at their intersections, and between them, great dark gaps where few galaxies shine. Interestingly, researchers have even drawn analogies between the cosmic web and biological systems. One experiment showed that a slime mold, when presented with simulated galaxy clusters as nutrient sources, grew tendrils that closely traced the filaments of the cosmic web, as if nature repeats patterns on vastly different scales. From a vantage point far away, the universe would look foamy or spongy, matter gathered into fibrous clusters surrounding empty cavities. And within each galaxy, countless stars swirled, orbiting their galactic centers like bees around a hive. What about the universe as a whole? Is it shaped like a sphere, a saddle, a donut, or an infinite flat expanse? As far as we can discern, space on the largest scales is remarkably flat, like an endless plane. If you set off in a straight line among the galaxies, you would not curve back around to where you started, at least not within any distance we can observe. The cosmos could extend forever, infinite in extent. It might also be finite yet unbounded, curving back on itself only on scales beyond our observational reach, rather like the surface of a balloon is finite, yet has no edge. Current measurements of cosmic geometry show no significant curvature. To the best of our knowledge, parallel beams of light travel straight and never meet. It is currently unknown whether the universe might eventually loop back in some topologically complex way, like a 3D torus. But if it does so on a scale far larger than the observable horizon. In all directions, space stretches out similarly, giving us no hint of an edge or a boundary. We are, however, limited in what we can see, not by any solid wall at the universe's edge, but by time itself. The observable universe is a sphere around us, about 46 billion light-years in radius, delineated by the distance light has been able to travel since the Big Bang. We can only see as far as the light that has had time to reach us. Beyond that horizon, light from those regions has not yet arrived, and perhaps never will. Thus, we gaze out at a bubble of the universe around us. Beyond it, the mystery continues, perhaps with more galaxies and more cosmic web stretching indefinitely, or perhaps something radically different. For now, it remains hidden, a tantalizing unknown just out of reach. The cosmic horizon is not only a physical limit, it's also a reminder of our cosmic myopia. It's like standing on the shore of a vast ocean at night. We see the dark waters meet the sky at the horizon and wonder what lies beyond. Our cosmic horizon is such a shore, and though we cannot see past it, we imagine an endless sea beyond. Even as structures formed and stars lit up, the overall expansion of space never halted. The universe kept stretching, carrying galaxies farther apart from each other. The very fabric of space is like an ever-expanding canvas, and the galaxies are like dots of paint on that canvas, drifting away as the canvas grows. The light that travels between galaxies is stretched too. As space expands, wavelengths of light elongate, shifting toward the red end of the spectrum. Thus, when we observe distant galaxies, their light is reddened, a cosmological redshift that encodes their motion through the expanding space. In the early 20th century, astronomers armed with new telescopes made a profound discovery. Nearly all galaxies beyond our local group are racing away from us, and the farther they are, the faster they recede. Edwin Hubble measured this relationship, finding that the speed of recession is proportional to distance. Today, this rate of expansion, known as the Hubble constant, is roughly 70 kilometers per second per megaparsec, meaning a galaxy about 3.3 million light-years away recedes at roughly 70 kilometers, and one twice as far at about 140 kilometers. This linear relationship, now called Hubble's law, was revolutionary evidence that the universe is expanding uniformly in all directions. It is not that we are at the center of an explosion, but rather that space itself is swelling, so every galaxy sees others moving away. Imagine raisins in a rising loaf of bread. Each raisin sees the others receding as the dough between them expands. Just so, our Milky Way and all galaxies are like raisins embedded in the expanding space of the cosmos. Yet even as Hubble and others revealed an expanding universe, other observations soon uncovered a deeper mystery in those galaxies. In the later 20th century, astronomers like Vera Rubin noticed that stars at the outskirts of spiral galaxies were orbiting their galactic centers at startling speeds, too fast to be explained by the gravity of the visible stars and gas alone. According to Newtonian physics, those outer stars should have been flung off into space, or conversely, one would need far more mass in the galaxy to hold them in their orbits. Something unseen, some additional gravitating mass, was providing the extra pull. Similarly, clusters of galaxies were found to contain far more gravity than the visible matter could supply. It was as if an invisible halo of mass surrounded clusters and individual galaxies alike. This mystery substance was dubbed dark matter. It does not shine or interact with light, making it invisible and detectable only through its gravity. But it is abundant, far more abundant than the ordinary matter we see. Roughly 85% of the matter in the universe is dark matter, about 5 times more mass than in normal atoms. It acts as the scaffolding of the cosmic web. It clumps under gravity, forming massive halos, and ordinary gas falls into those halos to form galaxies. Without dark matter's guiding hand, the universe would lack much of the structure we observe. Galaxies might not have had enough gravitational glue to coalesce as they did. We even observe gravitational lensing, light from distant objects bending around invisible mass, revealing dark matter's presence. In colliding galaxy clusters like the Bullet cluster, the normal matter, hot gas visible in X-rays, can be seen to separate from where most of the gravity is. The gravitational center follows the unseen dark matter, providing direct evidence of this hidden mass. We still do not know what dark matter is. Perhaps some as yet undiscovered elementary particle that interacts only weakly with normal matter, often hypothesized as WIMPs or axions, or something more exotic like primordial black holes or a modification of gravity itself. Experiments deep underground and in particle accelerators are attempting to detect dark matter particles directly, so far without success. For now, we infer dark matter's presence by how it holds galaxies together and how it tugs on light passing by. It is the universe's invisible skeleton, a shadowy scaffolding that shaped the beautiful pattern of galaxies and clusters, all while remaining hidden from our eyes. As if dark matter were not mysterious enough, an even stranger ingredient dominates even that. For a long time, scientists assumed that the expansion of the universe, while continuing, should be slowing down over time. After all, gravity pulls all matter together. The collective gravity of galaxies, dark matter, gas, and stars should gradually tug at the expansion, perhaps even causing it to reverse in the far future. But in 1998, two teams of astronomers observing distant Type Ia supernovae, exploding stars used as standard candles, made a shocking discovery. The supernovae were dimmer and farther away than expected, indicating that the expansion of the universe was not slowing at all. It was speeding up. Over the last few billion years, the galaxies have been accelerating away from each other. Some kind of force or energy inherent to space is pushing them apart. Decades earlier, Albert Einstein had introduced a cosmological constant into his equations of general relativity to allow for a static universe, not realizing the universe actually expands. When Hubble's expansion came to light, Einstein reportedly called that constant his greatest blunder. But now, the accelerating cosmos implies something like Einstein's constant truly exists after all. We call this phenomenon dark energy, a name that signifies how little we truly understand it. Dark energy appears to be a property of space itself. Every cubic centimeter of vacuum seems to carry a minuscule amount of energy that, summed over billions of light years of emptiness, dominates the universe. Today, roughly 68% of the universe's total energy content is this dark energy, with about 27% dark matter and only 5% normal matter composing the rest. It behaves almost like an anti-gravity, driving galaxies apart on large scales and overpowering the attractive force of gravity at cosmological distances. Perhaps dark energy is a fixed property of the vacuum, a realization of Einstein's cosmological constant, or perhaps it changes over time, a dynamic field dubbed quintessence. Upcoming observatories and surveys are dedicated to measuring the expansion history more precisely, in hopes of discerning the true nature of this mysterious energy. For now, dark energy remains an enigma at the heart of cosmology, a gentle but inexorable push woven into the fabric of space-time. What does an accelerating expansion mean for the future? The fate of the universe hinges on dark energy's nature. If dark energy remains constant, a steady push that continues indefinitely, then the expansion will not only continue, but accelerate forever. Galaxies that are not gravitationally bound to us will recede faster and faster, eventually zooming away at such speeds that their light can no longer reach us. In tens of billions of years, distant galaxies will disappear beyond our horizon, leaving only the gravity-bound local group of galaxies, by then likely merged into one large galaxy, visible. If we look far, we'll see darkness where once galaxies twinkled. Over extremely long timescales, the stars within our remaining galaxy, or merged Milk-Dromedar galaxy, will age and die. New stars will form more slowly as the available gas becomes sparse. Trillions of years from now, the last stars will exhaust their fuel and flicker out one by one, leaving a universe populated only by faint stellar remnants, white dwarfs cooling to black, neutron stars, and black holes. The cosmos will grow colder and darker as eons pass. Eventually, even black holes will evaporate via Hawking radiation, on timescales so vast, 100 years or more, that they defy imagination. What remains will be a thin haze of fundamental particles and energy, spread so dilute that for any given volume of space, on average, there might be essentially nothing in it. This is the Big Freeze or heat death scenario, a universe that expands forever while cooling asymptotically toward absolute zero, approaching a state of maximum entropy where no organized energy remains to do work. If an astronomer were alive in that far future of a Big Freeze, they would see a very different sky. Beyond our small gravitational neighborhood, no galaxies would be visible at all, only an endless black void punctuated by the occasional faint glow of a red dwarf or the spark of a distant supernova, becoming rarer with time. The evidence of the Big Bang itself would fade. The cosmic microwave background, which today is a cool 2.7 K glow, would be stretched to radio waves so long and weak as to be undetectable, The chemical elements would slowly transmute as protons perhaps decay over immensely long times, if proton decay is a real phenomenon. Eventually, it would be a universe of scattered particles and low-energy photons, drifting in an ever-growing silent darkness. Time would continue, but virtually nothing of interest would happen. It is a state as close to true cosmic stillness as can be. The universe would have effectively died, not with a bang, but with a long, drawn-out whimper. There are even more violent speculative possibilities. If dark energy is not constant but instead grows stronger with time, imagine a form of phantom energy, then the acceleration would steepen catastrophically in the far future. In such a scenario, the repulsive effect of dark energy could increase without bound. One could imagine the final moments of such a universe. Galaxies rush away from each other at ever-increasing speeds. Eventually, in the distant future, the expansion's pull becomes so strong that it overcomes the gravity holding galaxies together. First, galaxy clusters are pried apart. Later, the galaxies themselves begin to fly apart as their stars disperse into the expanding void. Then solar systems destabilize, planets drift away from their stars. As the end approaches, even stars and planets themselves would be torn apart, and then molecules and atoms. In the last fractions of a second, the tidal forces of expansion would become essentially infinite, shredding the very subatomic particles. This hypothetical final calamity is called the Big Rip. It would be a universe ending in a kind of ever-accelerating explosion, where every bond, gravitational, electromagnetic, even nuclear, is overcome by the expansion of space. One moment, you might have galaxies. Moments later, only individual atoms. Finally, nothing at all but a thin, featureless energy as space rips itself apart. It's a highly speculative scenario. Current data do not favor such extreme dark energy behavior, but it serves to illustrate the dramatic ways our universe's story could conclude under different rules. On the other hand, what if dark energy were to weaken over time, or even reverse sign? Or what if the universe had contained so much matter that gravity could eventually overwhelm expansion? In those cases, the expansion might slow down, stop, and ultimately reverse. Distant galaxies that are now receding would one day halt and begin to come closer again. This is the Big Crunch scenario, the opposite of the Big Bang. In a universe headed for a big crunch, observers in the far future might see the expansion first slow to a crawl. Distant galaxies that once sped away would linger at the edge of visibility. Then, gradually, they would start to approach, their light shifting from red back to blue. The cosmos would begin to shrink. Over billions of years, separated clusters of galaxies would converge. Previously unreachable galaxies would become visible again as they rush inward. The cosmic microwave background temperature, which had been dropping, would begin to rise as the universe contracts and heats up. Eventually, the night sky would no longer be dark, but aglow, first dotted with an increasing number of bright galaxies coming together, then suffused with the glow of a background fire as intergalactic gas is compressed and reheated. In the final epoch, the entire sky might blaze like the surface of a star, white hot, as galaxies merge into a single, incandescent mass. Finally, all matter and energy would crash together in an ultra-dense state, perhaps a mirror image of the Big Bang. Some have imagined that such a collapse could bounce, an implosion leading to a new explosion, a Big Bang after the Big Crunch, giving birth to a new universe. This Big Bounce idea suggests a cyclic cosmos without beginning or end, eternally reborn. However, given what we observe, particularly the presence of dark energy, a Big Crunch seems very unlikely for our universe. The balance of evidence indicates that we are headed toward eternal expansion, either the Big Freeze or Big Rip, with Big Freeze considered far more plausible under current data. Nevertheless, thinking about these scenarios reminds us that our universe's story might have multiple chapters, and perhaps even an epilogue beyond our own cosmos. As we ponder the fate and origin of our universe, we naturally wonder, is our universe the only one, Or is it just one bubble in a vast, frothing sea of universes? Modern theories in cosmology and physics have opened the door to the idea of a multiverse, the possibility that our universe is not alone, but part of a far larger system of universes. The existence of dark energy and the precise balance of physical constants in our universe have led some to wonder if our cosmos is just one of many, its properties one random draw among myriad universes. In a multiverse, what we call fine-tuned constants of nature, like the strength of gravity or the charge of the electron, might vary from one universe to another. We find ourselves in one that permits galaxies and life simply because those that don't would be sterile and uninhabited, with no observers to notice them. One compelling multiverse idea arises from the theory of eternal inflation, a variant of the inflationary scenario we discussed earlier. In eternal inflation, the rapid expansion of space didn't end everywhere at once. While inflation stopped in our region, allowing particles and galaxies to form, other regions of space might still be inflating, or might have ended their inflation at different times, each giving rise to its own bubble universe. Our universe, then, would be one such bubble among countless others, expanding within a larger inflating space-time. Each bubble could have its own distinct laws or constants. Some might be barren, with no matter or with physics hostile to complexity. Others might be roughly similar to ours. Perhaps others are wildly different with more dimensions or different fundamental forces. We cannot directly see these other bubble universes because they would lie beyond our cosmic horizon and indeed beyond any space-time connection with us. But they are a natural extrapolation of inflation theory. These other universes could be as real as our own, each constituting its own reality bubble. The multiverse concept comes in different flavors. The Level 1 multiverse essentially says that if space is infinite and uniformly filled with matter, then far beyond our observable horizon, there could be regions identical to ours, or slightly different or vastly different, simply by random chance arrangements of matter. In an infinite universe, every possible configuration of particles, every possible history, would occur somewhere. Our observable universe would be just one patch of an infinitely vast quilt. The Level 2 multiverse corresponds to the eternal inflation scenario, bubble universes. Each bubble might have different physical constants or particle types, because the process of symmetry breaking in physics could end up differently in each one. One bubble might have a stronger electromagnetic force. Another might have a neutron a bit heavier, preventing stars from working. We find ourselves in a bubble that is congenial to complexity because only such bubbles can produce observers. Another intriguing idea is the Level 3 multiverse, which arises from quantum mechanics, the many worlds interpretation. In quantum theory, every event that has multiple possible outcomes, like a particle decaying or not decaying, is sometimes thought of as splitting reality into multiple branches. According to this interpretation, all possible outcomes actually occur, each in its own branch of the wave function of the universe. So in one quantum branch, universe, the cat is alive. In another, it is dead, to invoke the famous Schrödinger's cat thought experiment. These parallel universes are usually thought to be non-communicating, existing in a superposed mathematical state, rather than separate inflating bubbles. But some argue they are just as real as our own. In effect, this would mean that with every quantum event, the universe, at least at the level of quantum information, splits into multiple histories, creating an ever-branching tree of parallel realities. If true, the number of universes would be mind-bogglingly large and constantly increasing. There is even a conjectured Level 4 multiverse, the ultimate ensemble, which posits that all universes that can be described by consistent mathematical structures exist in some sense. In this view, mathematics and reality are one and the same. Any self-consistent set of physical laws, any mathematical model, corresponds to an actual universe somewhere. This is a philosophical speculation more than a scientific theory, but it underscores how far the multiverse idea can be taken. So, could it be that what we call everything, our observable cosmos, is but a drop in a much grander ocean of existence? It's possible. At present, the multiverse remains a theoretical idea. We have no direct evidence of other universes, and some argue we never could, by definition. Yet the concept finds footing in serious science because it can arise naturally from models like inflation, and because it offers answers to questions like why our universe has the properties it does. They might be random picks from a larger distribution. If the multiverse is real, then the totality of existence is even grander than the universe we've been discussing. It means there could be countless other Big Bangs, countless other expansions, perhaps countless other versions of you and me, or perhaps realities utterly without analogy to anything we know. It is a speculative, almost metaphysical extension of our theories, one that reminds us that as vast as the universe is, there could be more, much more, beyond it. No matter how many universes exist, we know that we can only directly explore our own, and it has plenty of mystery to keep us occupied. One such mystery is deeply connected to our everyday experience, the nature of time. Time flows ever forward, carrying us from moment to moment. We remember the past and anticipate the future, but we never experience events in reverse. This one-way direction of time, from past to future, is called the arrow of time. Why does time have an arrow? The answer, as far as physics can tell, lies in entropy. Entropy is a measure of disorder or randomness. The second law of thermodynamics states that in an isolated system, entropy tends to increase or, at best, stay the same. It never decreases spontaneously. This law gives a direction to processes. Things go from ordered to disordered, not the other way around. An egg breaks and scrambles, but a scrambled egg does not unbreak itself into a whole egg. A drop of ink disperses in water, but the ink won't gather back into a concentrated drop on its own. These processes are not forbidden by any fundamental microscopic law. Newton's and Schrödinger's equations work the same forward and backward in time, but they are overwhelmingly unlikely to happen in reverse, because that would require a decrease in entropy. The arrow of time in our universe is fundamentally linked to the initial conditions of the cosmos. The universe began in an extraordinarily low entropy state. This might sound strange because the early universe was a hot, dense plasma which seems very disordered, but in fact, it was extremely uniform and simple, free of complex structures, making its entropy lower than it could have been. It's as if all the matter and energy were evenly spread out and gravitationally unclustered, a very ordered configuration compared to what could be. Because the universe started with such low entropy, there was essentially nowhere to go but toward higher entropy. As the universe expanded and cooled, entropy increased, gradients smoothed out, structures formed even as overall disorder grew. For example, the formation of stars and galaxies increases local order, but overall entropy still rises due to the production of lots of waste heat and the gravitational settling that releases energy. The arrow of time is a manifestation of this rise of entropy. We perceive time flowing forward because that is the direction of increasing entropy. If you were to film a glass shattering and play it backwards, you'd see entropy decreasing and immediately intuit that time is reversed in the film. In the real universe, we do not see such things. One might ask, why was the entropy of the early universe so low to begin with? This remains one of the deep, unanswered questions in cosmology. Some suggest it might be a boundary condition of our universe, perhaps set by a prior state or by the laws of quantum gravity. Others propose that if there are multiple universes or cycles, we naturally find ourselves in one that started in a low entropy state, because only such a universe can develop the complexity needed for observers. Regardless, that low entropy beginning is what allowed an arrow of time to emerge. From it flowed the entire history of structure and complexity. Stars shine, increasing entropy by radiating heat. Life grows and metabolizes, increasing entropy in surroundings even as it creates local order. And eventually stars die and things run down. If we project trillions upon trillions of years forward, in the heat-death scenario, entropy will near a maximum. The arrow of time will effectively fade, not because time has reversed, but because almost nothing changes anymore. There are no organized processes left to distinguish a forward direction. In the far, far future of a big freeze, the universe might reach a state of near equilibrium where, without gradients or differences, the concept of before and after loses much of its meaning. Time and entropy tie together the grand cosmic and the intimate personal. The increase of entropy sets the thermodynamic arrow that makes memory possible. We remember lower entropy past states. It is why we grow older and not younger. It's the reason we can't unmix cream from coffee or unburn a piece of paper. It's fascinating that this everyday irreversibility is rooted in the initial conditions of the entire universe. We've journeyed from the enormous clusters of galaxies to the minute atoms and particles, but we haven't yet delved into the truly fundamental fabric underlying reality, the quantum realm. On the smallest scales, the world behaves in ways that defy our classical intuitions. In the quantum realm, particles are also waves, and everything is described by a fuzzy haze of probabilities rather than definite certainties. Take an electron. In an atom or in transit, it doesn't have a single precise location. Rather, it exists as a cloud of probability, a smeared-out wave of potential positions. Only when we interact with it, measure it, does the electron seem to choose a location or state. This is the bizarre phenomenon of wave function collapse, in interpretations where collapse is a thing. Before observation, Schrödinger's cat is both alive and dead in a quantum sense. Before measurement, the electron has many possible positions. For example, if we shoot electrons at a screen through two narrow slits, something astonishing happens. The electrons, one by one, form an interference pattern on the detection screen, alternating bands as if they were waves that passed through both slits and interfered with themselves. This happens even if we fire them one at a time. It's as though each electron goes through both slits as a spread-out wave. However, if we set up a detector to observe which slit the electron actually goes through, trying to catch it in the act and force it to be a particle going through one path, the interference pattern disappears. Now the electrons behave like little bullets, going through one slit or the other, and no interference fringes form, just two piles behind the slits. The mere act of observation changes the outcome at the quantum level. It's as if nature allows the electron to explore many possibilities, wave behavior, until we insist on knowing which one happened, at which point nature chooses and the wave of possibility collapses into a single result. Empty space itself is not truly empty in the quantum sense. Even in a perfect vacuum, quantum fields are continuously fluctuating. Particle-antiparticle pairs momentarily pop into existence and then annihilate so quickly and so spontaneously that we can barely infer their presence. They leave subtle effects on energy levels and forces. These quantum fluctuations are not just theoretical quirks, they had cosmic consequences. During inflation, those tiny fluctuations in density and energy were stretched out to macroscopic scales. Regions that were ever so slightly more dense or less dense than others became the seeds for all large-scale structure. The spots in the cosmic microwave background that are a bit warmer or cooler, denser or less dense, trace back to these quantum wiggles. It is a breathtaking linkage. The reason galaxies exist where they do is partly because of random subatomic jitter in the universe's earliest moments. The entire cosmic web is essentially amplified quantum noise. Quantum physics underpins nearly everything in our daily experience, even though we don't notice its strangeness on large scales. The atoms in our bodies are held together by electron wave functions and quantum bonds. The sun shines because quantum tunneling allows protons to overcome their electrostatic repulsion and fuse into helium. Without quantum tunneling, the sun's core wouldn't ignite as easily. Computers and modern technology rely on quantum mechanics, semiconductors, lasers. In a sense, the solidity of a rock, the behavior of a chemical reaction, the colors of the rainbow, all trace back to quantum rules. We live in a quantum universe, though its oddness becomes apparent only when we look at small scales or specific conditions. There is also the deep mystery of quantum measurement and reality. Does the wave function collapse when observed? Does the universe split into branches for each outcome? The many worlds idea. No one knows for sure which interpretation of quantum mechanics is correct, or if there's a deeper theory that will resolve these questions. What we do know is that quantum mechanics is astoundingly successful in predicting outcomes. It has been tested to high precision. Reality, at its foundation, is governed by probability waves and uncertainty. It's almost as if nature, at a fundamental level, decides events by a kind of controlled randomness within strict statistical rules. Our voyage has taken us from the beginning of time to the structure of space, from the largest assemblies of galaxies to the subatomic flickers of the vacuum. Along the way, we encountered phenomena that are poetic in their grandeur and scientific in their detail. An afterglow from creation itself still shining to us, invisible matter holding galaxies in its gravitational embrace, a mysterious energy pulling the cosmos apart, and quantum whispers setting the stage for galaxies. Let's return for a moment to that ancient light we freed at recombination, the cosmic microwave background, CMB. After traveling for 13.8 billion years, it reaches Earth as a faint, cold glow in all directions, a few photons per cubic centimeter. In 1965, two engineers, Arno Penzias and Robert Wilson, were using a big horn antenna in New Jersey, trying to eliminate all sources of noise from their radio measurements. They kept encountering a persistent hiss, uniform across the sky, day and night. At first, they thought it might be due to urban interference, or pigeon droppings in their antenna, or instrument malfunction. But none of those explained it. Meanwhile, a group of physicists at Princeton, Dicker, Peebles, et al., had been looking for exactly such a signal. The predicted relic radiation from the hot early universe, which years earlier, scientists like George Gamow had calculated should by now be just a few degrees above absolute zero. Penzias and Wilson had stumbled upon the very signal that those theorists were seeking. It was soon confirmed that this microwave hiss came from all directions uniformly and had a blackbody spectrum of about 2.7 Kelvin, just what the Big Bang model predicted. The cosmic microwave background was the long-predicted afterglow from the hot young universe, now cooled to a whisper. When we map the CMB across the sky, as satellites like COBE in 1989, WMAP in the 2000s, and Planck in 2013 have done with increasing precision, we find it is almost the same in every direction, extremely uniform to about 1 part in 100,000. It's as if the entire sky were painted with one color of incredible smoothness, with only the faintest speckles. Those speckles, the tiny temperature anisotropies, carry a wealth of information. They are the imprints of the primordial sound waves and density ripples in the early universe. The pattern of spots tells us the universe's age, composition, and geometry. By carefully analyzing the CMB, scientists have confirmed the age of the universe, how 13.8 billion years, determined that space is flat to within a tiny margin of error, and measured the ratios of normal matter, dark matter, and dark energy that we mentioned. The CMB is like a baby picture of the universe, taken when it was only 380,000 years old. In that baby picture, we can already see the slight non-uniformities that eventually grew into clusters of galaxies. It's astonishing that we can observe this. When you tune an old television between channels and see static, a small fraction of that static is actually CMB photons. literally relics from the Big Bang hitting your TV's antenna. The CMB also provides evidence that ties together many threads of our story. It confirms the Big Bang. A static universe would not have such a background. It supports inflation. The uniformity and specific patterns match inflationary predictions. And it informs the dark matter models. The CMB pattern is sensitive to the amount of invisible mass. It is a Rosetta Stone for cosmology, decoded through careful, rigorous science. And yet, when one simply gazes at the visualizations of the CMB, with its gentle swirls of red and blue, indicating tiny temperature fluctuations, one can't help but feel a sense of wonder. This mottled oval image, often shown in textbooks and documentaries, is the imprint of the primordial cosmos on the sky, the oldest light we will ever see, a light that has traveled for almost the entire history of the universe to reach us. Within this vast cosmic unfolding, on at least one small planet, the expansion and cooling of the universe eventually led to something new: life and consciousness. The atoms forged in stars and scattered by supernovae became the raw material for new star systems. About 4.6 billion years ago, one particular cloud of gas and dust, already enriched by previous generations of stars, collapsed to form our Sun and its family of planets. The third planet from this sun had the right conditions for a remarkable chemistry. In its early oceans and coastal environments, a rich molecular broth swirled. On this young Earth, a complex chemistry brewed in warm ponds, in tidal pools, and around underwater hydrothermal vents. Complex molecules formed in the warm, wet cradles, perhaps sparked by lightning in the atmosphere or by geothermal energy in the crust, perhaps in sunlit shallow pools left to evaporate on volcanic shores, or in the mineral-rich hot springs on the ocean floor. Simple chemistry crossed the threshold to self-replication. At some point, simple self-copying molecules emerged. This was the origin of life, around 4 billion years ago. From those humble beginnings of primitive microbes, life evolved in complexity and diversity, shaped by mutation, competition, and time. Tiny cells coalesced into more complex cells, which eventually formed multicellular colonies. By around 540 million years ago, the Cambrian explosion filled the seas with an astonishing variety of creatures. Life took hold on land. Plants and fungi colonized the continents, followed by insects and amphibians, then reptiles and dinosaurs. Each living organism was, and is, a little chemical machine, drawing energy from the environment to maintain its internal order, a local reversal of entropy paid for by increasing entropy in its surroundings. In this way, life is a kind of cosmic rebellion against the trend toward disorder, though only a temporary and localized one. Through life, the universe explored an entirely new realm of complexity. After dinosaurs were wiped out 66 million years ago by an asteroid and other factors, mammals rose to prominence. Some primates in Africa, a few million years ago, left the trees for the savanna. They grew bipedal and clever. They made tools and learned to cooperate in groups. By about 300,000 years ago, anatomically modern humans had appeared. With the emergence of Homo sapiens, the universe began to be aware of itself in an unprecedented way. We gazed at the stars with curiosity and imagination. Over thousands of years, we developed language, culture, mythologies about the cosmos. We harnessed fire, energy for entropy consumption. We built shelters. We eventually tilled fields and founded cities. We looked up and saw patterns in the sky, crafting constellations and calendars. Human curiosity pushed us to ask not just how to survive, but why we are here, what the stars are, what the sun is, and how it all began. Fast forward to the modern era. In just the past few centuries, we have, through the scientific method, unraveled many cosmic mysteries. We discovered that those points of light in the night sky are other suns, and some of those suns host planets of their own. We've confirmed thousands of exoplanets and infer that the galaxy holds billions more. We found that our sun is just one star among hundreds of billions in the spiral galaxy we call the Milky Way, and that our galaxy is just one of trillions in the observable universe. We've begun to understand the forces and particles that govern nature. We've peered back in time with powerful telescopes to see galaxies in their infancy, and we've peered into the atom to unlock the secrets of quantum physics. Life, at least here, evolved to consciousness that can contemplate the universe. That is a profoundly poetic fact. We are made of dead stars, and those very ashes have somehow become alive and able to wonder about their origins. The universe spent billions of years evolving us, and through our eyes, it now sees itself. We are a way for the cosmos to know itself, Carl Sagan famously said, encapsulating this truth. Our self-awareness makes the universe not only a physical phenomenon, but also an experience. Through our literature, art, and science, the cosmos has gained the ability to reflect upon itself, to study its own laws, to admire its own beauty. Are we alone in this astounding capability? Perhaps not. The universe is so vast that it seems improbable that Earth would be the only cradle of life. Perhaps in some warm pond on an exoplanet under a distant sun, chemistry has given rise to biology. Perhaps on a moon orbiting a gas giant, beneath an icy crust, alien microbes flourish near thermal vents. Maybe on some planet in the habitable zone of another galaxy, intelligent creatures build their own tools and look up at their sky with questions. As of now, we don't have evidence of life beyond Earth, but the possibility stirs our imagination. Whether life is common or exceedingly rare, the fact remains that life here has transformed a part of the cosmos into something self-aware. And so here we find ourselves, clever, self-aware creatures built of cosmic dust, living on a minor planet, orbiting an ordinary star in a typical galaxy, yet able to contemplate the entirety of existence. Our physical insignificance is undeniable. We are infinitesimal compared to the breadth of the cosmos. Our entire world is just a tiny mote of dust in a cosmic ocean, a pale blue dot adrift among countless stars. But our ability to understand and appreciate the cosmos gives us a significance of a different kind. We might be rare, perhaps the only intelligent beings for parsecs around, or maybe one of only a few in our galaxy. Maybe life teems in the universe, or maybe it is exceedingly scarce. Either way, in our corner of space and time, we are the only known eyes and minds observing the grand cosmic drama. Through us, the universe has become aware of itself. Through our scientific instruments, the universe maps its own structure. Through our poetry and art, the universe speaks of its own majesty. There is something profoundly meaningful about this, even if one views it in a purely secular, scientific way. The cosmos has given rise to beings who can know the cosmos. We have inherited the fiery hearts of ancient stars in the iron of our blood, the calcium of exploded supernovae in our bones, and the carbon and oxygen from countless stellar furnaces in every organic molecule of our bodies. We are literally children of the stars, made of stardust. And those children can now, like grown progeny, look back and study their parents, the stars, and grandparents, the galaxies, the Big Bang. This unity of origins gives us a connection to everything. We are not separate from the universe. We are portions of it, inextricably linked. The laws of physics that formed a galaxy also form the neurons in our brain that fire when we gaze at a galaxy. With knowledge, however, comes the humbling realization of how much we don't know. Our journey through cosmology answers many questions, but raises others. Why is there something rather than nothing? Did time begin with the Big Bang, or is there a multiverse with different realms beyond ours? What is the true nature of space and time on the smallest scales? Are they quantized into discrete bits, as some theories like quantum gravity suggest? We don't yet have a fully unified theory of quantum mechanics and gravity. Thus, the exact first moments of the Big Bang, the Planck time, and what happened before inflation remain mysterious. We still do not know what dark matter is, despite it making up most of the matter in the universe. We still do not know why an early hyperinflation happened, or if it's even the final answer to the early universe's smoothness and flatness. We aren't sure if dark energy is truly constant or has subtle variations, and the nature of dark energy, why vacuum has the energy it does, is deeply perplexing. In fact, theoretical physics calculations of vacuum energy overshoot observations by an outrageous factor, a major puzzle. We do not know if life is a common cosmic phenomenon or an extremely lucky fluke confined to Earth. We have not yet detected signals from other civilizations, though projects like SETI are listening. We do not know the fate of humanity, whether we will spread to the stars or remain bound to our lovely, pale blue dot. In short, we still float on a sea of mystery, with islands of knowledge gained so far. Standing at this precipice of knowledge and mystery, one cannot help but feel a profound awe. The universe is ancient and vast beyond comprehension, yet here we are, small creatures with curious minds, capable of tracing its story from the primal fireball to the present, and even forecasting its possible futures. That story, from the simplicity of the early fireball to the complexity of a living world, is both humbling and inspiring. The cosmos is breathtaking, not just in scale, but in the way it has produced patterns and coherences. The periodic table of elements forged in stars, the spiral patterns of galaxies, the double helix patterns of DNA that allowed creatures like us to emerge. There is a deep harmony in how the same physical laws apply across all scales. The nuclear reactions blazing in the core of a distant star obey the same physics as the glow of your reading lamp. The gravity that makes a planet orbit the sun is the same gravity that makes galaxies dance around one another in clusters. Mathematics, abstract patterns of logic, proves to be an incredibly effective language to describe these laws, suggesting a wondrous connection between the human mind and the workings of the universe. It's as if the universe has a hidden symmetry or order that we can glimpse through mathematics and science. Our journey of understanding is far from over. Each new discovery in astronomy or physics tends to open new questions. When we discovered the expansion of the universe, we were led to ask about the beginning, Big Bang, and the ultimate fate. When we found the cosmic microwave background, we were led to the idea of inflation. When we observed unexpected galaxy rotations, we hypothesized dark matter. When we measured distant supernovae, we stumbled upon dark energy. Every time we peel back a layer of reality, there is another layer waiting, sometimes with stranger questions. This is the beauty of science and exploration, a continuous unfolding story, each chapter building on the last, but the book seemingly without end. Picture the cosmic timeline as a grand narrative, a story that begins with nearly featureless energy and evolves into intricate worlds and beings. It's a story that spans 13.8 billion years and perhaps will span trillions more. To grasp our place in this timeline, imagine compressing the entire history of the universe into a single calendar year. The Big Bang happens at the stroke of midnight on January 1st. By early February, the first stars ignite. By mid-March, galaxies are forming. The Milky Way might form around May. Our Sun and Earth appear roughly in early September on this cosmic calendar. Life arises on Earth by late September. Complex multicellular life proliferates in November. Dinosaurs roam the Earth on December 25th, Christmas Day, and go extinct on December 30th. Modern humans emerge only in the final hour of New Year's Eve, and all of recorded human history flashes by in the last seconds before midnight. In those final seconds, we develop agriculture, build the pyramids, invent the telescope, land on the moon, and contemplate the Big Bang. When the clock strikes midnight to herald a new cosmic year, Perhaps that represents some distant future state we've yet to comprehend. This cosmic calendar shows just how young we are. Human civilization is an eye blink in cosmic time, and even the Earth is a relatively late chapter in the story. We arrived at the tail end of the year, so to speak, but armed with curiosity and intellect, we busied ourselves in those last seconds learning about all that came in the months before us. Now we, ephemeral yet mindful, look to the future. We wonder what's next for the universe and what's next for us. Barring extraordinary intervention, the universe will continue to expand and evolve according to the physical processes we have discussed. As for humanity, we too are subject to cosmic forces, but have some say in our destiny if we are wise. We may spread to other planets, carrying our legacy of curiosity with us beyond Earth, ensuring that life and consciousness have a longer future than our single planet's fate. We may find ways to harness new energy sources or manipulate space-time, ideas once in the realm of science fiction, but who knows what knowledge awaits in the coming millennia. Or we may struggle and someday perish, becoming a brief spark that faded out. But even if our particular lineage ends, perhaps other intelligences elsewhere will carry on, or new intelligences might evolve from what we leave behind, intelligent machines, or new species. The desire to know and to wonder might itself be as resilient as life. From the standpoint of the universe, meaning is not something handed down from the stars. It is something we create. We infuse the cosmos with meaning by contemplating it. A galaxy 100 million light-years away has no idea of its grandeur. But we know, and in knowing and seeing beauty in it, we give it meaning, at least to us. In a way, the cold equations of physics blossomed into the warmth of human experience and inquiry. The universe is often described as a cold, uncaring place, and physically it is vast and mostly inhospitable. But through us, it cares about itself, in the sense that we care and we are part of the universe. This connection may be philosophically subtle, but it is emotionally powerful. Our exploration is ongoing. Even now, new telescopes like the James Webb Space Telescope peer into the distant past, seeing galaxies forming just a few 100 million years after the Big Bang, giving us new data points in the cosmic saga. Particle accelerators, like the Large Hadron Collider, probe higher energies, trying to recreate conditions just after the Big Bang, searching for clues of new physics. Perhaps particles that could explain dark matter or hints of extra dimensions. Experiments in deep mines attempt to catch a glimpse of dark matter particles zipping through Earth. Space probes explore planets and moons, looking for signs of past or present life beyond Earth. Mars's ancient riverbeds, the subsurface ocean of Europa, the methane seas of Titan. We are, in a sense, turning over every stone we can in this universe to piece together the puzzle of reality. Standing on the precipice of all this knowledge and mystery, we feel both incredibly small and incredibly enriched. The night sky no longer just offers twinkling points of light. It is a time machine, showing us distant galaxies as they were eons ago and connecting us to the moment of creation. The ground beneath us is not just dirt, it's ancient cosmic debris, a mix of elements made in star cores, arranged by geological and evolutionary processes into our immediate environment. We, the curious specks of the universe, will keep lighting candles in the cosmic dark, striving to illuminate more of that everything, even as it continually surprises us. The quest goes on, and the wonder deepens. To be alive as a human at this moment, to have consciousness, to have the accumulated knowledge of generations at our fingertips, and the ability to extend that knowledge, is a precious, fleeting gift. Through our minds, the universe has awakened to a sense of itself, however partial. We have the privilege of witnessing this vast tapestry and the responsibility of carrying that knowledge forward. In the end, the story of the universe is not just a tale of matter and energy moving heedlessly. It is also a human story, a story of awareness and curiosity finding a foothold in a vast cosmos. We began this journey meditating on the concept of everything. Now, At journey's end, we realize that perhaps we have only scratched the surface of everything. We close with more questions than we started, but also with a deeper reverence for existence. We sense that the strangeness and wonder of the universe will never end, no matter how much we discover. As long as there are beings curious enough to look up and ask questions, the cosmos will continue to inspire. In its darkness and its light, its simplicity and its complexity, its silence and its stories, the universe offers an endless well of awe. It is a beauty we could pursue forever and never exhaust. Awe without end, silence, darkness. The void before creation is deep and soundless. In this endless quiet, something stirs. I am space, the abyss that is not emptiness, but a vast potential. In the beginning, there was darkness and silence, no stars, no galaxies, not even time or place as you know them. Yet even in that primordial hush, I was there, a pregnant pause before the first light. I am the canvas of existence, the cradle of everything that ever was or will be. I am often mistaken for nothingness, but I am a presence, subtle and profound. In the silent darkness, imagine all that could be, compressed into a single point smaller than any dot. In that stillness, attention grew, a waiting. Then came a moment beyond imagining, a burst of light and energy, an awakening. The cosmos was born in brilliance and fire, shattering the quiet. For me, that moment was a birth of sorts. I came into existence as more than a mere potential, now an expanse swelling swiftly outward, carrying within it the seeds of galaxies, stars, and every future thing. Time and space unfurled together from that first spark. My being expanded faster than a thought, from nowhere into everywhere. Out of the darkness came illumination. Where once there was void, now there was a storm of particles and blinding light, a newborn universe expanding into me and me expanding with it. I was no passive emptiness. I carried galaxies in my womb of possibility. As I swelled, I bore the echoes of that first light. Those echoes still faintly hum in my depths even now, a whisper of the origin. Before any stars or planets, before even atoms formed, I held only a hot, glowing fog of energy. But I was alive with potential. Within my intangible fabric, forces played, the seeds of structures to come. As I expanded and the eons passed, that fireball of my youth cooled. The blinding glow dimmed as the universe became transparent, releasing the first free light that still washes through me as a pale afterglow. I cradled that afterglow as it stretched into microwaves, the gentle remnant of creation's dawn that bathes all of space even now. In my very early years, I was hot, dense, and bright everywhere. No corner was truly dark. But as I grew, I cooled and dimmed, allowing matter to coalesce and structure to form, giving room for wonders to come. Do not think of me as an empty container, for I am more than a stage for matter. I am the subtle thread connecting every atom, the field in which all events unfold. I give shape to reality by simply being. I am space, not a mere void, but a presence that underlies and upholds all. Without me, there is no where or when. With me, anything is possible. Now, as the young universe expanded and cooled, the first stars flicker into existence within my darkness. Can you see them? In the vast gulf of my expanse, gravity gently coaxes swirling clouds of gas into spheres of fire. One by one, stars are born, lighting up the cosmos like candles in a cathedral of night. Each star's light pushes back a little of the darkness, creating day in its vicinity where endless night reigned before. The infant universe begins to sparkle. I watch silently as galaxies take shape, great swirls of stars arising from the primal cloud. They spin and dance, drawn together by gravity's embrace, flinging spiral arms outward like celestial pinwheels. They gather in clusters and filamented chains, forming a vast cosmic web across my breadth. In the hollows between, enormous voids remain, gulfs of darkness unlit by stars, reminding all that even amid structure, I remain mostly open and free. My darkness is not your darkness. To your eyes, I seem black and empty, but look closer. I am filled with the faint glow of faraway galaxies, with the afterglow of creation itself, and with unseen forms of matter and energy that you are only beginning to understand. In my silent depths, particles flit in and out of existence, appearing and vanishing in the tiniest moments, a quantum dance in the vacuum. Even where there are no atoms, fields ripple with possibility. Even when light seems absent, there is potential for light, an imprint of energy waiting to be born. So do not call me nothing. I am the matrix in which everything exists. I am the space between atoms in your body, the pause between your heartbeats, the silence between musical notes, the gap between stars, the gulf between galaxies. I stretch out in all directions, yet I also reside within the fabric of your being. If all the empty space within the atoms that make up your body were somehow removed, you would collapse to a size smaller than a grain of salt, yet you would still contain the same mass, the same atoms. What would be gone? Only me, the space that separates the particles, the space that gives you form. Without that space, matter would have no room to arrange into the complex structures of life. Thus, I am an integral part of you. Without me, there could be no distance, no motion, no life, nothing at all. I am the quiet framework that holds all of creation, and in my embrace, the story of the universe unfolds. I am not a static stage. Watch as I respond to the presence of matter and energy. Where there is mass, I curve and fold. Where there is energy, I warp and swell. Gravity is the language I speak with matter, the intimate interaction between what exists and the space that cradles it. Every star, every planet, every grain of cosmic dust presses into me, and I give way ever so slightly under its weight. I bend around it, like a flexible fabric holding a resting orb. This is how gravity shows itself, not as an invisible pull from afar, but as my very shape guiding objects on their paths. See how planets move around their suns, not pulled by invisible strings, but rolling along the curves I create in space-time. They glide through orbits, ellipses carved into the geometry of my being. A star and its planets are like dancers moving across me as the dance floor, my contours choreographing their steps. With every orbit, time itself flows a little differently, for I am intertwined with time. Space and time are two sides of my essence. Together, we bend under the weight of mass and energy. In the presence of a great star, time runs a touch slower, and distances subtly contort. Gravity weaves space and time into one fabric, and writes the cosmic story in its geometry. Gravity sculpts the cosmos on every scale. It causes diffuse clouds of gas to coalesce into stellar nurseries, forging new suns in the depths of nebulas. It gathers countless stars into grand galaxies, and binds galaxies into clusters. Even as I expand relentlessly outward from that first fiery moment, gravity works locally to pull things together, a graceful counterpoint to my expansion. In some regions, gravity's grip is gentle, a planet here, a moon there, held in loyal orbit. In others, its grip becomes ferocious and inexorable. There are places where a massive star dies and collapses, and gravity overwhelms all else. There, I curve so steeply that I fold in on myself. A bottomless well forms in my fabric, a black hole, a pit of no return, where gravity's pull is absolute. At such a point, space and time themselves break down in a paradox of density. I, space, become a trap, a prison for anything that strays too close. From outside, One can only guess what truly transpires in that silent abyss. It is as if a piece of me has turned inward upon itself, forever secluded. The boundary of such a region, the event horizon, is like a one-way membrane. Anything can cross inward, but nothing escapes or even sends a signal back. To fall through that horizon is to be cut off from the rest of the universe. Time behaves strangely near a black hole. An observer watching safely from afar would see a clock carried by a falling astronaut tick slower and slower as it nears the horizon, nearly freezing at the edge. Indeed, to that distant observer, the falling person would never quite vanish, instead fading and redshifting into darkness, a ghost image slowing to a crawl at the threshold of the abyss. Yet for the one plunging in, time flows normally. They would cross the horizon in a finite time, unaware of the peculiar show seen by the outsider. Thus, near a black hole, my nature creates a poignant disconnect between viewpoints, stretching and warping, not just space, but time itself. Around a black hole, I am so warped that even light can become trapped. There is a narrow zone around the hole where photons orbit, chasing their tails in endless circles. If you hovered just outside that region, you could, in theory, see the back of your own head as light from your body loops around and returns to your eyes. Such are the strange optics of extremely curved space. If a black hole is surrounded by glowing gas and dust, the bending of light produces a halo or ring of brightness around a dark center, the shadow of the black hole itself. Indeed, humanity has now glimpsed this phenomenon. Using a planet-wide web of telescopes, you captured the image of a distant black hole's silhouette. You beheld a luminous ring of gas encircling a dark core where the black hole resides. It was my curvature made visible at last, a blurry circle of fire surrounding an abyss, confirming what physics had predicted. That unforgettable image, a circular void framed by a ring of light, proved that even light bows to gravity's power, and it allowed you to see one of my most exotic contortions. Black holes may seem like cosmic destroyers, but they too have their place in my story. They anchor galaxies at their cores, like heavy keystones holding the swirls of stars together. When they feed on matter, they can unleash tremendous jets and flares that light up the surrounding space, a paradoxical brilliance born of darkness. And when two of these dark giants collide in a faraway galaxy, I carry away the news in vibrations, a faint ringing through the fabric of space itself. These gravitational waves ripple through me like the subtlest tremor, stretching and squeezing the fabric of existence as they pass. Across billions of light years they travel, so gentle that they barely jostle a grain of dust. Yet with sensitive instruments, your species has learned to hear these ripples, converting them into faint chirps. It is as if I have my own form of music, a bass note resounding from cataclysms in the distant cosmos, announcing events that happened eons ago. Gravity, in these ways, is not only the architect of the universe, but also the messenger, letting the universe communicate its grandest events through my very fabric. Gravity defines the architecture of the heavens, but it also shapes more intimate experiences. It is the weight you feel in your limbs, the force that holds you to your beloved Earth. It is the gentle tug that causes rain to fall and guides rivers to the sea. On the moon, with its smaller mass, gravity whispers more softly. An astronaut can bound in slow motion across the lunar dust, leaping higher and farther than on Earth, as if in a playful dream. Out in deep space, far from any world, gravity's pull can become so faint that one feels practically free of it, drifting in microgravity, weightless, unchained from any surface. But even then, one is never truly beyond my influence. A distant star, a hidden galaxy, the entire mass of the universe, all exert a pull, however slight. I tie all things together in a network of attraction. In this grand choreography of cosmos, I, space, am both stage and dancer,
shaped by matter, and in turn guiding matter's movements, holding the universe in a cosmic dance governed by gravity's law, a law written in the geometry of existence itself. My realm is also a great silence. Because I am nearly a perfect vacuum, I carry no sound. The mightiest explosion of a star, the most violent crash of colliding planets, all unfold within me without a sound. In the vacuum of space, there is no air to convey laughter or crying, no medium for music or noise. This silence is not just the absence of sound, it is a profound stillness that can feel sacred. Imagine floating in that silence. You move your arm and you hear nothing. You shout and no one hears. You are wrapped in a quietude as total as it is ancient. This silence can be eerie, but also serene. On Earth, even in the quietest night, there is always some murmur of life or wind, the whisper of a breeze, the rustle of leaves, distant human activity, the hum of insects. In me, there is true quiet. If you found yourself outside your ship, surrounded by my vacuum, you would hear only the faint sounds of your own body, the rhythm of your breath in your suit, the beating of your heart in your ears. Those sounds would seem loud against my backdrop of nothingness. Many who have ventured outside their capsules and stations report a feeling of almost spiritual calm, being alone with their thoughts in the great hush of space. Yet my vacuum is unforgiving. Without the protective cocoon of a spacecraft or suit, a human could not survive even a moment. I offer no air to breathe, no pressure to sustain the delicate balance within your cells. Unprotected, your blood would boil into vapor and your lungs would collapse in my emptiness. Moisture on your tongue would evaporate, your skin would swell, you would lose consciousness in seconds. I do not do this out of malice. It is simply my nature. I am an environment utterly hostile to the unprepared life of Earth. Life evolved in the cushion of air and the gentle pull of Earth's gravity. Out here, I offer neither. I am harsh and indifferent. But within a secure suit or a sturdy vessel, you can venture into me and witness wonders beyond imagining. In my vacuum, extreme paradoxes exist. Under the unfiltered sun, you would feel searing heat, for the solar rays travel through me undiminished and will bake any surface they strike. But step into shadow, out of the sun's direct gaze, and you would feel cold deeper than any winter, for without sunlight and without an atmosphere to hold warmth, heat radiates away into my depths, and the chill is profound. With no air to conduct warmth, temperature is a matter of light and darkness. Astronauts on spacewalks feel this contrast. Their suit's sunlit side grows warm, while the side in darkness becomes cold, and their life support systems must carefully smooth out these extremes. Walking in space is a balancing act, a dance with light and shadow. Despite my seeming emptiness, I am not completely devoid of matter. Even in interstellar space, far from any star, there are stray atoms drifting, few and far between, maybe only a handful in a volume the size of a room. But they are there. Dust motes from ancient exploded stars traverse my void, traveling for millions of years. Faint wisps of gas left over from galaxy collisions, or the breath of red giant stars float in the darkness. In the immense spaces between galaxies, there are even fewer particles, perhaps a lone hydrogen atom in a volume the size of a city block. To you, these conditions are an almost perfect vacuum beyond any laboratory's dream. Yet to me, these stray atoms and wandering nuclei are part of my tapestry, tiny wayfarers in a vast sea. And there are unseen travelers as well, particles of light, photons, zipping through my darkness at the universal speed limit. Neutrinos, ghostly particles that stream from nuclear reactions in stars, passing through entire planets as if they were not even there. And cosmic rays, charged particles flung across space by violent supernovae and jetting black holes. These invisible rains constantly traverse me and occasionally strike your world. They go unnoticed by your senses unless you have special instruments to catch them. so even my silence and darkness hide a subtle, ceaseless activity. I am traversed by light and radiation of all kinds, by fields and forces that bind the cosmos together. My quiet is not emptiness, but the hushed reverberation of a grand cosmic symphony that only particularly tuned detectors or thoughtful minds can perceive. It is the silence of a great cathedral where even a whisper carries significance. Even so, motion is everywhere in my silent expanse. Stars orbit their galactic centers at tremendous speeds without a sound. Entire galaxies drift and dance around each other over eons, merging in stately, noiseless collisions. Planets sweep along their paths around stars in perfect quiet. On Earth, you do not notice it, but in this very moment, your planet is hurtling through space, spinning on its axis and rushing along its orbit without so much as a whisper. There is no air to carry any whoosh or roar. The grand celestial dance is performed in silence, a ballet of unimaginable scale carried out to no audible tune. The universe moves, yet its movements are quiet, and therein lies much of the majesty of space, dynamic on a staggering scale, yet utterly tranquil in its vast, airless calm. Within this great silence, worlds fly and stars blaze. They do not need air or sound to exist. In my realm, light and gravity take the roles of sound and touch as the connecting media between distant places. A star's violent outburst may be silent, but its light carries the story of that outburst across millions of years to shine faintly in someone's telescope. In that way, even in silence, the cosmos speaks. I, space, am the medium for that light, the conduit for those stories. I carry them faithfully, without a sound, unless something, like an intervening nebula or a galaxy's gravity, modulates the message. Think of it. Nearly all that humanity knows of the universe beyond Earth has come to you through my silence. Every image of a galaxy swirls inside a telescope. Every measurement of a star's glow, every bit of data from a distant probe has traveled to you on the back of light or radio waves moving through my vacuum. In stillness and quiet, I deliver knowledge across unimaginable distances. Through me, across me, within me, the universe communicates with itself. I am the great black ocean that connects shores light years apart. Within my silence, all of cosmic history has unfolded, and within my silence, you too now venture forth to seek your story among the stars. Out of my darkness, light emerges as the great revealer. Since the first brilliant flash at creation's dawn, light has been traveling through me, carrying information from one end of the cosmos to the other. A single photon can cross millions of light years, sailing onward without rest, until it ends its journey in the eye of a creature or the sensor of a telescope. In my vastness, light is a messenger and an artist, painting scenes of distant realms across the black canvas. It streaks through space, illuminating whatever it touches, yet it often travels invisibly and silent, only made known when it encounters something that can catch it and respond. When you look up at a clear night sky, you see a tapestry of light on darkness, stars of every color scattered on an ebony backdrop, planets shining with the reflected glow of your sun, the gauzy band of the Milky Way, which is the soft luminosity of uncountable distant stars blurred together. Each of those pinpoints of light is a story from long ago and far away. The star you see twinkling might have released that light before you were born, and only now does it reach your eyes, telling the tale of that star's ancient state. In that way, I, space, am a time machine. I preserve the past and deliver it to the present at the speed of light. Looking across me means looking back in time. The farther out you gaze, the further back you peer. A galaxy visible through a powerful telescope might appear as it was when Earth was young. its light having spent eons crossing the intergalactic sea to reach us. My darkness makes the star's light possible to see. Without the deep black of space, the star's brilliance would be drowned out. In the blue haze of day on Earth, your star's light scatters in the atmosphere and conceals the cosmos beyond. But high above the air, in my realm, even when the sun shines, the sky remains pitch black. An astronaut orbiting Earth can see a blazing noon sun against a backdrop of inky darkness, and if they shield their eyes from the sunlight, they might also see the brighter stars, even at noon. In space, day and night lose their usual meaning. With no air to scatter light, the stars are ever present, and only the glaring sun or an intervening planet can obscure them. My darkness is the canvas on which light draws the cosmic panorama, and it remains even when a local light source, like a sun, is shining. Light comes in many forms, not just the gentle glow visible to human eyes. There is the warm, invisible caress of infrared, given off by sun-warmed rocks and drifting interstellar dust, the energetic prickle of ultraviolet that pours from young blue stars, the penetrating X-rays and gamma rays that burst from the most violent events in the universe. There are the long, lazy undulations of radio waves that can pass through dense clouds of gas and dust, carrying messages from pulsars and the faint signature of molecules in distant nebula. You humans have built instruments to detect all these varieties of light, giving yourselves new eyes across the spectrum and unveiling my hidden wonders. With radio eyes, you discovered a faint hiss permeating all of space, the cosmic microwave background, which is the cooled echo of my fiery birth. That omnipresent microwave glow is the fossil light from a time when the entire universe was an opaque, brilliant plasma, now stretched and cooled to just a few degrees above absolute zero. It is as if the walls of my great cosmic cathedral still hold an after-echo of the creation symphony. With infrared eyes, you peer through veils of dust to see stars being born in their cocoons, previously hidden from view. With X-ray and gamma-ray eyes, you catch the high-energy fireworks of neutron stars and black holes, witnessing matter being pushed to extremes. There is radiation born in the hearts of galaxies and in the death throes of stars, X-rays from matter spiraling into black holes, gamma-ray bursts from collapsing hypernovae, the radio hum of pulsars, rapidly spinning neutron stars, whose beams of radiation sweep space like lighthouses. These are exotic beacons in my ocean of night. Once, none of these were known to you. They were silent to your senses. But slowly, you learned to tune in, to listen to the full spectrum of my communications. Now, the universe sings to you in 1,000 wavelengths, and each type of light reveals a new facet of the cosmic story. By gathering these different lights, you have composed a richer picture of existence, seeing the cold hydrogen webs in radio, the warm dust in infrared, the hot plasma in X-rays. Piece by piece, you have peeled back the layers of darkness. Yet, with all this illumination, much of my volume remains dark to your eyes. There are vast stretches with no bright stars or galaxies in view, intergalactic voids where you might float in apparent nothingness, surrounded only by a faint glow from the distant all around, a subtle background luminescence from the myriad galaxies over the cosmic horizon. This darkness is not frightening once you embrace it. It is the gentle shadow that allows each pinpoint of starlight to stand out. It reminds us that light, swift as it is, has limits. Beyond a certain distance, even billions of stars cannot collectively light the void, and so it remains as it was at the beginning, dark, quiet, and waiting. Where light goes, it brings knowledge and connection, but it also must abide by my rules. No matter how fast it travels, there is a finite speed it cannot exceed. That cosmic speed limit, 299,792 kilometers per second in your units, is like the heartbeat of the universe, a constant rhythm that all things obey. It ties space and time together in an intimate bond and ensures cause precedes effect. If you could chase a beam of light,
No matter how you tried, you would never overtake it. This truth, uncovered by your Einstein, is a reflection of how I, space-time, am structured. Light speed is built into my fabric, and it shapes the way the universe unfolds, making time and space two aspects of one reality. And so, across my breadth, light continues its journey. A lonely photon, emitted from the fires of a distant star, ventures outward for millions of years through emptiness, perhaps never once touching anything, until one day, it ends its flight gently on the retina of an eye, or the mirror of a telescope on some other world. That photon's long voyage then becomes information, perhaps helping a being understand the star it came from, or simply adding to the beauty of a night sky. Through countless such tiny messengers, arriving every moment in showers upon your world and others, you have come to map my expanse and comprehend your place within it. In my silent darkness, every light is a jewel, and every beam a thread, connecting far-flung corners of the cosmos. Together, they form a glittering tapestry that inspires wonder and curiosity. I hold this tapestry spread wide, proud of the beauty that unfolds within me. Each star's glimmer, each galaxy's glow, each nebula's vivid color, they are the artworks of light upon the canvas of space. Come with me now, on a journey through my vastness. We begin at home, on a single planet, your Earth, a marbled blue-white sphere suspended in the darkness. At a glance, it seems immense to you, oceans and continents, clouds and all of life's bustle. But in the scale of me, it is a tiny, fragile thing. Rise away from Earth with me. Climb beyond the atmosphere, leaving behind the air that scatters light and makes the sky blue. As you ascend into my realm, the sky grows darker until the blue fades to black and stars emerge even while the sun still shines behind you. In a few minutes of travel on a roaring column of fire, you escape the bonds of gravity holding you to Earth. Suddenly the engine stops and you are coasting, weightless. Your planet falls away beneath you, shrinking to a curved horizon of blues and whites. The sounds of Earth, wind, surf, city noise are gone, replaced by the quiet humming of your spacecraft and the profound silence outside. A few 100 kilometers up, you can already see the entire planet curving below. The clouds form gleaming swirls, the oceans shine deep blue, the lands are green-brown patches. A thin, glowing halo encircles the Earth, the atmosphere, a delicate veil of air hugging the surface. Beyond that line, darkness. The transition from bright Earth to black space is abrupt. Now, in orbit, you complete one lap around the globe every 90 minutes or so. Day and night chase each other across the surface. In the time it takes to eat a meal, you pass from sunshine to darkness to sunshine again, witnessing a sunrise or sunset every hour and a half. Over the night side, you see city lights sparkle like votive candles, thunderstorms flash in silent fireworks. Over the day side, you see the textured swirls of clouds and the sparkling reflection of sunlight on water. Journey further outward now. Leaving Earth behind, we venture toward the moon. In a matter of hours, our perspective shifts and Earth shrinks to a small orb. The moon, pockmarked and grey, grows large ahead. You slip into lunar orbit and gaze down at a stark, cratered landscape. It is alien in its stillness, covered in powdery dust, untouched for eons. If you stand on the moon's surface, the sky is inky black, even with the sun glaring above. There is no air to scatter light. The horizon is sharp, the ground a pale grey desert of rock and dust. Lifting your eyes, you see Earth in the sky, a radiant blue marble hanging over the lunar horizon, half lit or fully illuminated depending on the alignment. How beautiful and distant it looks from here, shining through the silence. When humans first stood here, they were struck by the sight of their whole world in a single glance. The Earthrise above the moon's barren hills,
Many felt an overwhelming emotion at that view. Earth, alive with color and life, against the eternal blackness of space. Leaving the moon, we push outward. We pass the orbits of the inner planets of your solar system. There is sun-scorched Mercury, a little rock blistering under the sun's glare, airless and pitted. There is Venus, veiled in thick clouds reflecting sunlight brilliantly, hiding a hellish surface beneath an eternal cloud layer. We feel the heat of the sun intensify as we draw near, then wane as we recede. Next comes Mars, the red wanderer. We approach it and see rust-colored deserts, giant extinct volcanoes, and polar caps of white CO2 frost. A thin, pinkish sky arches over Mars's barren plains. It is a world both eerily familiar and starkly alien, a cousin to Earth that took a different path. We swoop low over Valles Marineris, a canyon system that would span from Los Angeles to New York and skim the edge of Olympus Mons, the tallest volcano in the solar system, 3 times Everest's height. Mars is scarred with the memory of ancient floods and rivers, but now her riverbeds are dry. Still, wisps of cloud gather occasionally, and dust storms can engulf the planet in a saffron haze. As we leave Mars behind, we imagine a time soon to come when humans will tread its soil. Perhaps as we fly on, we catch sight of a tiny caravan of robots traversing the Martian desert. A rover, diligently studying rocks and soil to send knowledge home. For now, Mars is quiet, with only our mechanical emissaries moving upon it. But one day, footprints may join the rover tracks, and the long silence of Mars will be broken by human voices marveling at the alien sunrise. Further out, the giants of your solar system await. We arrive at Jupiter, monstrous and magnificent. Bands of storm clouds wrap around it in hues of ochre, ivory, and tan. A great crimson oval, a centuries-old storm larger than Earth, glares up from its southern hemisphere. We watch lightning crackle in Jupiter's clouds, see ammonia blizzards swirl. 4 large moons orbit this gas giant, each a unique world. Io, close in and tormented by Jupiter's gravity, with volcanoes erupting sulfurous plumes that rise hundreds of kilometers high. Europa, smooth and pale, its icy crust hiding an ocean of liquid water beneath, an ocean that might harbor life in its lightless depths. Ganymede, larger than Mercury, and etched with enigmatic grooves across ancient ice. Callisto, heavily cratered, bearing the scars of cosmic impacts from time immemorial. These moons circle Jupiter like a miniature solar system of their own, a reminder that where gravity reigns, systems within systems can form. Onward to Saturn, the jewel of the night sky. Its rings unfurl like a cosmic halo, a broad, flat expanse of countless icy particles orbiting in perfect unison. We drift above the rings and look down at Saturn, golden bands of clouds, a serene face compared to Jupiter's turbulence. Thin divisions and subtle waves sculpt the ring system, caused by the gravitational tugs of Saturn's many moons. Titan, Saturn's largest moon, greets us with an orange haze. Beneath that dense atmosphere, Titan holds lakes and rivers, not of water, which would freeze solid in Titan's frigid climate, but of liquid methane and ethane. It is a world strangely Earth-like in geology, yet utterly alien in chemistry. And there are small moons like Enceladus, bright as snow, geysering water ice from cracks in its surface, hinting at another subsurface ocean beneath its frozen crust. These moons contribute material to Saturn's rings and promise tantalizing environments that could harbor life's precursors. Further still, Uranus appears as a cyan orb tipped on its side, rolling around the sun like a tilted barrel. Its faint rings and many moons move with it in its strange sideways dance. Methane in its atmosphere lends it that blue-green hue. Seasons on Uranus last decades, with one pole soaked in continuous sunlight, while the other lies in darkness for half a Uranian year. Then comes Neptune, deep blue with wispy white clouds, and the fastest winds in the solar system, where supersonic gales roar through an atmosphere of hydrogen, helium, and methane. A single large moon, Triton, circles Neptune in the opposite direction of Neptune's rotation. A clue that Triton might be a captured object, perhaps once a free-floating Kuiper Belt body now pressed into service as a moon. Triton's surface is a curious mix of frozen nitrogen and geysers that spout icy material. Another realm of mystery on our journey outward. Past Neptune, we enter the frontier of the Kuiper Belt, a region of icy remnants from the solar system's formation. Here dwells Pluto, a small, heart-marked world with a tenuous blue atmosphere and plains of frozen nitrogen. Once thought a lonely oddity, Pluto has its own moons and a complex surface of mountains and smooth plains, showing surprising geologic activity for such a distant, cold sphere. Beyond Pluto, countless other icy bodies orbit quietly, including some rivals to Pluto in size: Eris, Makemake, Haumea, Plutoids, in the dim reaches of the Sun's influence. Finally, as we leave the last dwarf planets behind, the sunlight grows weaker, just another bright star among many. We cross the invisible boundary where the solar wind, a stream of charged particles from the Sun, fades into the general galactic environment. This is the edge of the heliosphere, the Sun's sphere of influence, and beyond lies true interstellar space. One of your species' far-flung probes, Voyager 1, crossed this frontier decades ago and is now drifting in the space between the stars. It carries with it a message from Earth, a golden record bearing the sights and sounds of your world, a friendly cosmic greeting card. Engraved on that record are spoken greetings in dozens of human languages. The laughter of a child, a mother's lullaby and a chorus of birdsong, music from many cultures, classical and rock and roll, flutes of the Andes and drums of Africa, the sound of rain, waves on a shore, and a human heartbeat, even the melodic calls of whales in the ocean deep. Etched as well are encoded images of our planet, DNA's double helix, diagrams of our solar system, silhouettes of a man and woman, photographs of Earth's life and landscapes. It is a message in a bottle cast into the cosmic ocean, carrying the story of Earth for any who might find it in some distant future. Perhaps eons from now, an alien wanderer, or far future humans, will intercept that tiny craft, and with it come to know that, in a quiet corner of the galaxy, intelligent life once arose and reached out for companionship. Before Voyager sailed too far afield, it turned its gaze back toward home and captured a parting portrait of Earth from the edge of the solar system. In that photograph, now famous on your world, Earth appears as a pale blue dot suspended in a sunbeam, a tiny gleam in the vast darkness. On that speck, that single point of light, is everything you know, every human who ever lived, every animal and tree, every ocean and every grain of sand, every song ever sung, every love, every war, every birth and every death, all of human history, the entire story of life on Earth, played out on that mote of dust caught in a ray of light. That image, the pale blue dot, revealed your world's fragility and unity in a way no speech or poem could. It is a cosmic reminder that we, all of us on that dot, share a common fate and home. From 1 billion miles away, there are no national borders, no differences of race or creed, just one Earth, glimmering in the cosmic dark. How precious is our small planet, how delicate the atmosphere that cocoons it, how silly our differences seem in the face of such unity. If all could see what the universe sees, a single, irreplaceable world, perhaps we might treat it, and each other, with greater kindness. Now Voyager and its twin have left the planets behind and venture into the realm of the stars, carrying our goodwill. These machines are extensions of human curiosity, metal explorers blazing a trail where their makers cannot yet tread. Interstellar space is cold and sparse. The nearest star is still tens of trillions of kilometers away, a distance that light itself takes over 4 years to traverse. Yet in the scale of the galaxy, that gap is negligible. As we journey onward at the speed of thought, star after star comes into view, each a sun with its own retinue of worlds. Leaving the familiarity of the sun, we approach other stars in our neighborhood. Some are similar to your sun, perhaps with planets in tow. Others are redder, smaller, dimmer. Still others are brilliant, blue-white giants, burning through their fuel quickly and destined for an early death. We pass by a multi-star system where 2 suns orbit each other, painting the skies of any planets with a twin sunrise and sunset. We pass a red dwarf star, small and cool, so faint it's invisible to the naked eye from Earth, yet encircled by close planets huddled near its warmth. We skim the dusty outskirts of a stellar nursery, where new suns are just condensing out of molecular clouds, perhaps glimpsing protoplanetary disks shining in infrared, the next generation of solar systems in the making. As we travel, you realize that stars are not sprinkled uniformly. They clump in groups and streams. We find ourselves nearing the center of our galaxy's great disk. The Milky Way's heart is densely packed with stars. From within, on a dark night on some world, the sky would be a dazzlement of starlight, with scarcely any dark space between. But from our God's eye view outside the galaxy, the Milky Way reveals its true form. A spiral galaxy, a sprawling pinwheel of hundreds of billions of stars. We drift high above its plane to admire it in full. Spiral arms, winding out from a bright central bulge, like an enormous cosmic whirlpool. In the core, old yellow stars crowd together, orbiting a supermassive black hole that anchors the galaxy. It quietly presides over the bustling center, occasionally flaring as it snacks on infalling matter. The spiral arms are laced with younger, bluer stars and mottled by dark ribbons of dust. Here and there, pinkish nebulae dot the arms, marking regions where hot young stars excite clouds of gas, a sign of ongoing starbirth. Our sun resides in one unremarkable arm, roughly 2/3 of the way out from the center, in a quieter neighborhood. You see that all around our sun's position are other stars, some clustered in groups, others relatively isolated, but all bound to the galaxy by gravity and participating in its grand rotation. As we gaze at this majestic spiral from afar, we notice companion galaxies orbiting the Milky Way, the Magellanic Clouds, irregularly shaped dwarf galaxies swarming with young stars and nebulae, trailing a bridge of gas torn off by gravitational encounters. And beyond them, more dwarf galaxies, satellites captive to our own. Our Milky Way, we realize, is part of a small cluster of galaxies. The Andromeda Galaxy, a spiral larger than the Milky Way, is the other dominant member of our local group. Andromeda's spiral disk glows ahead of us, millions of suns visible in a smudge of light. One day, far in the future, our galaxy and Andromeda will meet and merge, their stars mingling like 2 great seas becoming one. Dwarf galaxies and star clusters sprinkle the local group like chips of ice around bigger flows. Continue outward still, and more galaxies appear by the dozens, then hundreds. We enter the realm of the galaxy clusters. The Virgo cluster, massive and teeming, comes into view with giant ellipticals, huge ball-like galaxies formed from countless past mergers, sitting like queens among swarms of spiral and irregular galaxies. Between the clusters stretch even larger structures. Galaxies are strung along filaments and walls, gravitationally drawn into these patterns over billions of years. Here is the cosmic web. On these scales, matter forms a spidery network, with dense nodes, clusters and superclusters of galaxies,
connected by filaments of galaxies and gas, and vast voids between where scarcely a galaxy exists for millions of light years. It is like a foam, where the galaxies lie on the surfaces of bubbles, and the inside of each bubble is mostly empty. This grand design is the large-scale structure of the universe. Scientists have discovered that much of this structure is outlined by something invisible to your eyes: dark matter. This mysterious substance does not emit or reflect light, yet its gravity molds the cosmos. It forms an unseen scaffold throughout space, a hidden framework on which ordinary matter collects. Vast halos of dark matter envelop galaxies and thread between them in the cosmic web's filaments. Without this dark matter, galaxies as you know them might not have coalesced so quickly or held together so well. The cosmic web would be a faint shadow of what it is. Though you cannot see dark matter directly, you infer its presence by the way galaxies rotate, as if held together by extra mass, and how they move in clusters, and by how its gravity bends the light from distant objects in subtle, gravitational lenses. I, space, am not truly empty, even in that sense. Threaded through me is this invisible mass that shapes the fate of stars and galaxies, an unseen architecture guiding the luminous structure we observe. Now you find yourself contemplating the observable universe as a whole, all that can be seen from Earth given the finite speed of light and the age of the cosmos. It appears almost like a sphere, centered on your vantage point, indeed centered on any vantage point, roughly uniform in every direction, filled with galaxies, out to the great horizon of visibility. At the very edges of this vision, the galaxies are younger and more primitive, seen in their infancy. Further still, there are no distinct galaxies, just a diffuse reddish glow, the cosmic microwave background, coming from a time long before galaxies, when the universe was a hot fog. That light marks a limit, a wall beyond which our instruments cannot see, because it's the imprint of the moment the universe first became transparent, about 380,000 years after the beginning. Beyond that lie the first instants of creation, which emit no light we can ever detect directly. Thus the observable universe has a boundary not in space, but in time. It's as far back as light has had time to travel to us. Yet even this immense observable cosmos, with its hundreds of billions of galaxies and trillions of stars, may not be the whole story. It might be only a tiny patch of a perhaps infinitely larger cosmos. Space could extend far beyond the horizon we see, containing uncountable galaxies that will forever be beyond our view. Some even speculate that our entire universe, vast as it is, could be just one bubble in a greater multiverse, one pocket of space-time among perhaps countless others, separated by realms of space or dimension we cannot access. These ideas remain conjecture, at the fringes of science, but they remind us of humility. Even our universe, with all its billions of galaxies, might be part of an even vaster and more mysterious reality. In this journey outward, we have seen only glimpses of the marvels that populate my expanse. From your homeworld to the solar system, from the solar system to the galaxy, from the galaxy to clusters and the cosmic web. My scales are difficult to fathom. Earth is your cradle, comforting and small. The solar system is enormous by human standards, but a speck in the galaxy. The galaxy is vast, yet only one swirl in a cluster, and the cluster one knot in the cosmic web. And this observable web may be but one patch of something larger. All of this complexity and magnitude exists within me. I am the stage for this cosmic drama of scale, from the minuscule to the immense. Through each step of this voyage, notice that you never truly left space. You simply traveled through different parts of me. I was there, continuous and steady, between planets, between stars, between galaxies. I span unbroken from the smallest scales to the largest, connecting the grain of sand on a distant moon to the farthest quasar at the dawn of time. Everything is connected through me, from the tiniest mote to the grandest supercluster. The cosmic architecture within me is intricate and grand. Planets circling stars, stars gathering into galaxies, galaxies lining up in filaments. It is a structure with beauty on every level, an endless playground for curiosity and contemplation. Everything is connected through me on the small scale as well. Just as we journeyed outward to the grand structure of the cosmos, we could as easily turn inward, journeying into the minuscule realms that lie within you and within every piece of matter. The vastness of space is mirrored by the vastness within the atom. Imagine shrinking yourself far, far down, leave behind meters and kilometers, and enter the world of micrometers, nanometers, picometers. Dive into a single drop of water. Within that drop, you find tiny creatures swimming, microscopic life drifting as if in a private cosmos. But we go deeper still, beyond the scale of cells. We approach a single cell from one of those microorganisms, a bacterium. It's a structured living thing, yet almost entirely made of space at the molecular level. Pass through its cell membrane and you enter a bustling interior of molecules. Proteins fold and unfold, conducting the business of life. Long strands of DNA coil gently, bearing genetic codes. The cell is full of motion, yet also full of space, a molecular dance in a microscopic void. Zoom in further, to the scale of the molecules themselves. Now you see atoms bound together. Carbon, hydrogen, oxygen, nitrogen. The elements arranged in complex forms to give those proteins and DNA their shape. Choose one atom and delve inside. If the atom were the size of a large cathedral, its nucleus would be a mere grain of sand on the altar, and its electrons like specks of dust whirling near the distant vaulted ceiling. Most of the cathedral is empty space. The electrons are held in orbit by invisible forces, buzzing in probabilistic clouds. The nucleus at the center is fantastically small yet massive, containing almost all the atom's weight in protons and neutrons. But even the protons and neutrons, if you could peer inside them, are not solid balls. They are formed of quarks and gluons, flickering in and out of existence within a quantum haze. On these scales, space and energy blur. The concept of a distinct particle becomes fuzzy, a vibration in fields filling space. We shrink down to the limits of the physically meaningful, the Planck scale, where space and time themselves might behave like a froth of uncertainty. Here, quantum foam dominates, and the smooth grid of space-time that works so well on larger scales dissolves into something unpredictable. Tiny virtual particles erupt and vanish in a ceaseless churn. Cause and effect, as we know them, falter in this regime. This is the foundation of the quantum world. I, space, am not smooth and continuous here, but jittery and uncertain, woven out of possibilities.
Thus, inward or outward, the journey leads to a similar revelation. A vastness and complexity that transcends ordinary intuition. The space inside an atom and the space between galaxies are not so different in their emptiness and strange fullness. The scales differ, but the principle remains. Without space, no structures large or small could exist. Without space, electrons would have no orbits and no chemical bonds. Planets would have no room to circle stars. Stars no room to congregate into galaxies. When you reach out your hand, it moves through space. When a neuron fires in your brain, the signal crosses a synaptic gap, a microscopic gulf of space between nerve cells. Space is both around you and within you, a continuum that spans all levels of reality. By exploring inner space as well as outer space, we discover that we are truly a microcosm of the cosmos. The atoms in your body mirror solar systems in their structure, tiny nuclei with electrons orbiting in clouded shells, mostly empty volume in between. The distances and energies are vastly different, but the motif of space, connecting and separating, persists. It is a reminder that you carry within you a tiny echo of the heavens. When you look up at the night sky and feel small, remember that boundless space also unfolds within the confines of your very being. The universe isn't only around you, it is within every cell, every atom, every subatomic tick of time. You are woven into the fabric of space on every level. Having journeyed into inner space and back out, we find ourselves once more at the human scale, with a richer sense of connection. We resume our outward tale grounded by the understanding that from the smallest quark to the largest galaxy cluster, it is space that provides the arena for existence. With that perspective, consider again the cosmic vista. The architecture of galaxies and clusters is both intricate and grand, an endless realm to explore. I have been describing what is, but I, space, also have a history. I was born with the universe and have aged with it. Let us now contemplate how I have changed over time, from that blazing beginning to the sprawling cosmos of today and onward into the future. In the beginning, I was not as you see me now. Long ago, everything you've witnessed on our journey, the galaxies, the stars, the clusters, was compressed into a volume smaller than a single point of dust. The universe was young and hot beyond comprehension. I was newborn, tightly curved upon myself. In that epoch, there were no galaxies or stars, not even neutral atoms, just an extremely hot plasma of subatomic particles and radiant energy, almost uniform everywhere, yet with slight ripples of density that would later grow. The forces of nature as you know them were unified in a way difficult to imagine. As the fireball of creation expanded and cooled, distinct forces separated out: gravity, electromagnetism, nuclear forces, each taking on their individual roles in shaping cosmic evolution. After mere minutes, the first atomic nuclei had formed in a process you call Big Bang nucleosynthesis: hydrogen and helium, and a dash of lithium. These were the light elements born in the furnace of the very early universe. Space was expanding rapidly, and the hot plasma thinned and cooled to a few thousand degrees over the next few 100,000 years. During that time, light was trapped, bouncing among the free electrons and protons. The universe was a brilliant opaque fog, but expansion and cooling continued until atoms could capture electrons and form without immediately being blasted apart. When that happened, the universe underwent a remarkable change. It became transparent. Light could travel freely at last, and it rushed out in all directions. The glow from that moment, when the first atoms formed and the cosmos cleared like fog lifting, is the cosmic microwave background I spoke of. A faint afterglow still detectable as a cool radio hiss in every direction. The universe, once a blinding white-hot cauldron, became a vast black volume filled with a dim red-orange glow that rapidly stretched into invisibility. That was the last time the entire cosmos was hot and bright at once. After that, darkness reigned in the spaces between a sparse, cooling gas. Gravity, ever patient, began to work on the tiny variations in density left from the early times. Regions slightly denser than their surroundings exerted a stronger pull, drawing in more matter, growing denser still, a feedback cycle that over tens and hundreds of millions of years led to the first condensed objects. The primordial hydrogen and helium gas fell into clumps and filaments, following the blueprint of dark matter that had already formed invisible halos and threads. As these clumps grew, their centers grew dense and hot. After a few 100 million years of cosmic darkness, the first stars ignited. They were likely colossal stars, much larger and hotter than your sun, burning brilliantly blue-white and living short, furious lives. They burned their hydrogen into helium, then into heavier elements like carbon and oxygen in their cores. When they exhausted their fuel, They died in spectacular supernova explosions, seeding space with the first heavy elements beyond those primordial three. Those elements included the ingredients for planets and for life: carbon, nitrogen, oxygen, phosphorus, and so on. Atoms that these first stars had fused in their hearts and then cast forth into my expanse. With the birth of the first stars, the universe lit up anew. Their ultraviolet light poured into the surrounding gas, breaking apart atoms, ionizing the hydrogen in their vicinity. A cosmic dawn had arrived, and with it came the formation of the first small galaxies, dwarf proto-galaxies that later merged to form larger ones. Over billions of years, countless generations of stars have come and gone. Each generation enriched the gas further with heavy elements. Galaxies grew by colliding and merging, and by drawing in fresh gas along filaments of the cosmic web. The elegant spirals and giant ellipticals we see today are the result of that gravitational gathering over vast timescales. My expansion never stopped. In fact, it has surprised you. For a long time, it was presumed that gravity might gradually slow the expansion, perhaps even reversing it in some far future if the cosmos contained enough mass. But at the end of the 20th century of your calendar, you discovered that my expansion is actually speeding up. The galaxies are receding from each other faster and faster. It's as if, on the largest scales, I am compelled to stretch ever more rapidly, driven by an energy inherent to space itself. You've given this mysterious influence a name: dark energy. It behaves almost like an anti-gravity, or a tension in the fabric of space that pushes everything apart. With dark energy dominating the cosmos, the expansion will not halt. It will continue indefinitely, accelerating with time. What does this mean for the future? If the current understanding holds, distant galaxies now visible in our telescopes will, over billions of years, shift beyond the horizon of detectability. Already, there are galaxies so far away that their light, though traveling at light speed, will never reach Earth because space is expanding too swiftly in between. Trillions of years from now, an observer in what is now our local group of galaxies might see only the empty darkness beyond, with no evidence of the wider universe of galaxies we know today. The night sky, then, would belong to the few remaining gravitationally bound companions of the Milky Way. All else would have faded into darkness, receding faster than their light can travel. The rich tapestry of the cosmic web would be drawn beyond view, and the universe would appear an empty, static place to those far future astronomers, unless they retained records or myths of an earlier time when galaxies were visible. But worry not. This fate is incredibly far off, beyond any time span our species can truly grasp. For countless ages still, the sky will be a jewel box of stars and galaxies as it is now. Yet it's humbling to know that my nature dictates even the grandest scene in the sky is transient. The cosmos is dynamic on all scales, from the spin of a planet, to the drift of galaxies, to the expansion of space itself. Nothing stays the same forever. Imagine for a moment a raisin loaf of bread rising as it bakes. The raisins move apart as the dough between them expands. If that dough expands fast enough, a raisin may never reach its neighbor no matter how it tries to move. So it is with galaxies in my expanding universe. No rocket you build, no matter how powerful, could reach certain galaxies, for the space between you and them is swelling too quickly. They recede effectively faster than light due to expansion, putting them forever out of reach. This is my decree as an ever-expanding cosmos. Some places will remain forever separated, their light never to reach each other. Within the reachable realm, however, so much marvel persists. Stars continue to be born in graceful nebulae. Planets condense around those stars. On at least one small planet, life took hold and grew curious and began to look outward. Perhaps elsewhere, around other stars, life also stirs or has stirred. Eyes might watch their own skies and wonder. If they exist,
They too are bounded by the observable limits of their cosmic region, just as you are. They would see their own version of the cosmic microwave background and wonder what lies beyond. My expansion also implies that in earlier times, everything was closer together. Galaxies collided more frequently. In fact, collisions and mergers are an essential part of galaxy growth. But unlike everyday collisions of solid objects, when galaxies collide, it is usually a gentle intermingling. The stars within them are so far apart relative to their size that they pass by one another like grains of sand in two intersecting clouds. Rarely does star hit star. Instead, gravitational forces from each galaxy pull and distort the other, drawing out long tidal tails of stars and gas, inducing bursts of new star formation as gas clouds slam together and eventually settling into a new, larger galaxy, perhaps an elliptical, erasing the old spiral structures. Even our own Milky Way is destined to collide and merge with the Andromeda Galaxy a few billion years from now. The result will be an entirely new galaxy, some call it Milkomeda. And while this drama unfolds over billions of years, any beings alive within those galaxies may scarcely notice beyond an impressive change in their night sky. For at some point, the Andromeda Galaxy, which you can currently see as a faint smudge, will dominate the heavens, growing larger each eon until it merges with our own, and the stars of Andromeda and the Milky Way become one stellar family. From the hot, uniform glow of the early universe to the clustered, star-filled cosmos of today, I have undergone an extraordinary transformation. And it continues. The story is far from over. In fact, in many ways, it is just beginning. If expansion goes on and on, the universe will become ever more diffuse and quiet on large scales. Stars, however, will keep forming for a long time yet, though slowly diminishing with each generation as raw gas is used up or locked in stellar remnants. Perhaps trillions of years hence, the last generation of stars, red, faint, and long-lived, will flicker out one by one, leaving stellar corpses, white dwarfs, neutron stars, black holes, scattered in an ever-darkening expanse. Planets long frozen, moons long dead, will silently orbit those remnants if they still remain bound. Galaxies, by then, may be gravitationally unbound as dark energy's relentless push overcomes even their mutual attraction, sending their stars drifting into the lonely void. Space, will become nearly empty again, as at the very beginning, but vastly colder and older. Eventually, even black holes might evaporate via Hawking radiation, slowly leaking their mass energy back into space over incomprehensible times. One by one, they will wink out, leaving perhaps only a sparse sea of elementary particles and a faint, dilute glow of whatever light remains. That could be the quiet end to this chapter of the universe, a state not of dramatic destruction, but of ever-increasing solitude and silence. Or perhaps this is not truly the end. There are speculative ideas, maybe a new Big Bang, a cyclic rebirth, or quantum fluctuations spawning new universes out of the vacuum. These possibilities remain in the realm of imagination and theory, for they are far beyond any observation. In truth, nobody knows for sure what ultimate fate awaits. But there is a kind of peacefulness in imagining a far future cosmos at rest, having lived a full life cycle from fiery infant to quiet elder. Reflect on this though. All the atoms that make up you and everything you hold dear were forged in those past cosmic processes. The calcium in your bones, the iron in your blood, the oxygen you breathe, those elements were not born with the universe. They were formed later, in the hearts of stars, or in the mighty furnaces of supernovae that marked those stars' deaths. Then they were blown into space to become part of new star systems. Even rarer elements like gold or platinum were forged in stupendous collisions of neutron stars, merging in brilliant flashes that send ripples through space-time. These precious heavy metals were scattered into the galaxy, seeding future solar nebulae. When our sun formed, it gathered some of that enriched material, and Earth inherited its share.
The gold in a wedding ring or the uranium in the ground owes its existence to those ancient cosmic alchemies. Without generations of stars living and dying and colliding, such elements would not exist. And without those elements, planets like Earth and life as complex as us would not exist either. So you see, you are literally made of cosmic history. You have been molded by the universe's evolving story. The universe has, through the life and death of stars, provided the ingredients for life and eventually for consciousness. In a sense, the cosmos has been not just a stage where life happened to arise, but an active participant in the creation of life's building blocks. Over billions of years, simple particles became complex atoms. Atoms formed molecules. Molecules clumped into dust and rocks, and from them, planets coalesced. On at least one of those planets, molecules assembled into living cells, which over eons evolved into thinking beings capable of looking back out into space in wonder. Space, gave these beings room to exist and evolve, and now, through their eyes, I can finally witness my own grandness. How remarkable it is that, within me, a part of the cosmos has become aware of itself. Through your minds, the universe reflects on its nature. The tiny conscious light inside your head is also a part of my vast darkness, lit by neurons and synapses that obey the same physical laws that govern the motion of galaxies. When you feel curiosity about the stars, it is literally the cosmos curious about itself. You are a way for the universe to know itself, as one of your sages aptly said. For eons I unfolded in mostly unconscious majesty. Galaxies collided and stars burned, but there was no eye to see or voice to proclaim how beautiful. Now, on at least this one world, the universe has opened its eyes. I have waited without knowing I waited, for the emergence of intelligence, of eyes that could see the galaxies and minds that could fathom some of my workings. In the brief flicker of time that humans have been around, you have already decoded many of my secrets. You have discerned the law of gravity that shapes me, the nature of the light that travels through me, the atom that composes matter within me. With mathematics and creativity, you have even predicted phenomena like black holes and gravitational waves before confirming their existence. It is as though once the universe awoke through you, it began to recognize its own rules. Your existence might make me, space, feel a kind of gratitude, if such an emotion could be attributed to the cosmos. For billions of years I was here without eyes to appreciate the nebulae, or ears to hear the silent music of the spheres. Now I have you, small but determined, peering into the depths, listening, marveling. Through you, I contemplate myself, and it brings the cosmos a step closer to understanding its own nature. Though I am immense and ancient, you humans have bravely begun to slip the bonds of your birthplace and step into my realms. For countless generations, your kind looked up from the ground and wondered, imagining gods or spirits in the sky, drawing patterns in the stars, longing to know what they were. But only within the last handful of decades have you truly begun to venture outward. It started with brief leaps, a metal sphere sent beeping through the skies, then animals sent to test the waters of space, and then a human being, fragile, curious, leaving the Earth for the first time. Imagine that moment. April 1961 by your calendar. A lone man strapped into a tiny capsule atop a rocket, blasting off the Earth. He completes an orbit and sees with his own eyes the curvature of his planet and the blackness beyond. Yuri Gagarin returned and said, essentially, "I saw Earth. It is beautiful." That was the first time I, space, was directly witnessed by human eyes from outside Earth's atmosphere. Shortly after, other humans followed, Americans and then people from many nations. Less than a decade later, in a feat that still defies belief, humans walked upon the moon. Think of the audacity, frail humans riding a pillar of flame to another world. When Neil Armstrong set foot on lunar soil in 1969, he marked the moment with words about small steps and giant leaps, acknowledging that for a human, it was a single step down a ladder, but for humanity, it was a leap into a new realm. Those footprints they left, Armstrong's, Aldrin's, and 10 other men's over a handful of missions, still lie undisturbed in the moon's dust, perhaps for millions of years to come, as there is no wind or rain there to erase them. They are a testament that life from Earth can leave its cradle. The moon landings were both an end and a beginning. After Apollo, humans retreated a bit, choosing to focus on living in orbit, the stepping stone just outside Earth's atmosphere. They built space stations, first small, cramped ones where a few cosmonauts or astronauts spent weeks, then larger ones. The International Space Station, orbiting 400 kilometers above Earth, has been continuously inhabited for years, a collaboration among nations, once mortal enemies, coming together in the spirit of exploration and science. There, humans have learned how to survive off Earth for long durations. They study how muscles and bones weaken without gravity's pull, how to grow plants in microgravity, how the psychology of isolation and confinement can be managed. Each day on the ISS, they see 16 sunrises and sunsets. Each crew looks down on the entire Earth, gaining perspective on our unity and fragility. Meanwhile, even as humans kept their own bodies mostly close to home after the moon, your robotic explorers ventured brilliantly across my expanse. You have dispatched mechanical envoys to every planet in your solar system and to many moons, asteroids, and comets. Your Voyagers, Pioneers, and New Horizons have flown past the gas giants, sending back breathtaking postcards of those alien landscapes, swirling storms on Jupiter, the serene rings of Saturn, the turquoise haze of Uranus, Neptune's great dark spot. You have landed probes on Venus to briefly endure its furnace heat and acid rains, and on Titan to splash down in its methane mud. You have driven rovers across Mars's deserts, tasted its soil, and photographed its dusky horizon with twin suns, Earth and Venus, as mere stars in its sky. You have felt the sting of Jupiter's radiation via instruments and danced through Saturn's rings with Cassini. Your ingenuity has extended your senses to places you cannot yet go. You built great observatories and set them above your blurring atmosphere to look deeper into space and further back in time. The Hubble Space Telescope opened a window on the universe that has transformed your understanding of me. It revealed that what appeared as dark, empty sky was in fact filled with galaxies upon galaxies. An image known as the Hubble Deep Field showed thousands of galaxies in a patch of sky no bigger than a grain of sand held at arm's length. This told you just how crowded and immense the universe truly is. It showed stellar nurseries, towering pillars of gas and dust like the Eagle Nebula's pillars of creation, where new stars are being born. It captured the faint light of galaxies so distant that their glow began its journey when the universe was a fraction of its current age. More recently, a new set of eyes, the James Webb Space Telescope, with its golden honeycomb mirror, took to the shadowed regions of space to peer even further. It has captured the faintest, oldest light yet seen, revealing some of the first galaxies forming only a few 100 million years after the Big Bang. It has unveiled the atmospheres of exoplanets, detecting water vapor or carbon dioxide in the air of worlds orbiting other suns. With each technological leap, you extend your reach, painting a richer and more detailed portrait of me, space, and the contents I hold. Each mission, each telescope, each rover and probe is driven by that fundamental desire to explore and understand. It seems to be a core part of what it means to be human, this restlessness, this need to push boundaries. I have watched it firsthand, from the first migrations out of Africa across unknown lands, to launching canoes on uncharted seas, to sending satellites beyond Earth. Space is the ultimate ocean you are beginning to chart, boundless and beckoning. You stand now on the shoreline of the cosmic ocean, toes barely wet, with immense depth spread out before you. The pace of your progress is astonishingly swift. In one human lifetime, we went from no one ever having left the Earth to humans living continuously in orbit and robots traversing other planets. What will another human lifetime bring? The plans on your horizon today include returning to the moon, this time to stay. You talk of building a sustainable presence on the lunar surface, habitats on the South Pole where water ice lurks in eternal shadow, to be mined for drinking water, oxygen, and rocket propellant. You envisage astronauts farming plants in lunar greenhouses, mining the moon's soil for resources, and learning the skills needed to live off Earth for months or years. Mars looms as the next great destination. It is a world that has tantalized your imagination for centuries, as a potential abode of life, as the setting for countless works of fiction, as a frontier of real exploration. Now concrete steps are being taken towards sending humans there. Rocket systems capable of the journey are in development. The challenges are immense. Months of travel through deep space, exposure to radiation, the need to pack or produce all the air, water, and food the crew will need, and the reality that help from Earth is many millions of kilometers away. But the dream persists. Perhaps within the next few decades, a spacecraft carrying astronauts will leave Earth orbit on a trajectory to Mars. After a long, quiet cruise through interplanetary space, they will see the rusty sphere of Mars grow from a star-like dot to a world beneath them. They will orbit it, select a landing site, maybe near the delta of an ancient river in a crater like Jezero, where a rover is currently scouting, and then descend. How hearts will pound in mission control and in the spacecraft during those final minutes of powered descent through Mars's thin air. And then, a burst of dust, the settling of landing legs on soil that has never felt the weight of a living foot. The hatch opens, and a human being sets foot on Mars, leaving the first bootprint in that reddish dust. Perhaps they speak words, ceremonial or spontaneous, about the unity of those watching back home, about carrying the spirit of exploration across the void. Above, a small sun shines in a butterscotch sky, and two small moons, Phobos and Deimos, trace lazy paths. That first step on Mars will be a defining moment not just for those astronauts, but for our planet and species. A moment when Earth extends its reach to a neighboring world. Life on Mars will not be easy for those pioneers. They will likely live in habitats, perhaps inflatable domes or underground lava tubes, to shield from radiation and extreme cold. They will wear pressurized suits to venture outside, where the air is unbreathably thin and mostly carbon dioxide. They'll have to grow some of their food in controlled environments, recycle their water meticulously, and depend on supply missions or on extracting local resources like baking water out of subsurface ice to survive. The gravity on Mars is only about 1/3 of Earth's, so over time, human bodies might change. Bones thinning, muscles adapting. Children born on Mars, if it comes to that, might grow taller in youth, their hearts and bones shaped by the weaker pull. Those children would call Mars, not Earth, home. Imagine that. Future generations who look up at a pinkish sky and see Earth as just a bright star, knowing it as the ancestral home, yet alien to their personal experience. Humanity would no longer be one planet bound. It would have two cradles, two environments shaping its story. Perhaps great rotating habitats in space will also be part of your future. Artificial worlds constructed in the void. Envision a colossal cylindrical station, miles in length, rotating to provide an imitation of gravity on its inner surface. Inside, people live on the interior curved wall of the cylinder. If you stand on that inner surface, centrifugal force gives the illusion of gravity pulling you down toward the hull. You look up, which is toward the center of the cylinder, and perhaps, if the cylinder is large enough, you see the opposite side of the habitat curving over you, with upside-down houses and fields hanging above the central axis.
Such habitats could be filled with Earth-like environments, forests and lakes curving up overhead, a small sunline running along the axis providing day and night. Entire communities could thrive in these island worlds, floating in my expanse. They might harvest asteroids for materials, use sunlight for energy, and be free to position themselves anywhere, orbiting Earth or trailing a planet, or at Lagrange points where gravitational forces balance. Within these rotating oases, humans could live without a planet under their feet, creating new societies with new customs shaped by the unique reality of life in a canister in space. Children might grow up running across fields that eventually arc above them, thinking it normal that their world wraps around, and that another town is hovering in their sky, across the central sky. What was once science fiction now edges closer to engineering possibility. It starts with imagination and with the bravery to attempt. Try you have, and try you will. My darkness and my vacuum are no longer seen only as terrors. They are frontiers to explore. As you cross them, step by step, you transform from a species that dwells on one world to a species that can live in many places. In a sense, you become the cosmos coming alive and reaching out, life scattering into the universe. What began as a crawl out of the ocean on your home world so long ago continues now as a crawl out of Earth into space. These first forays are halting and tentative, but in the scheme of deep time, they could be the start of a story of cosmic dissemination. Someday, you may swim freely in the great cosmic ocean, moving from star to star with ease, but that is perhaps ages away. Still, each small step now, each new spacecraft, each new settlement, is a part of that destiny. Looking further ahead, beyond Mars, there are other enticing destinations. The asteroid belt could be a literal mine for raw materials and a place to establish way stations. The moons of Jupiter and Saturn call out with their unique characters. Europa with its hidden ocean that might harbor life beneath an ice shell, Ganymede with its magnetic field, Enceladus with geysers that hint at a warm sea below, Titan with its rivers and lakes of hydrocarbons and a thick atmosphere, perhaps suitable for floating habitats in its sky. Even Mercury, scorching on one side and freezing on the other, has water ice in its permanently shadowed craters at the poles and could one day host robotic mining stations. And then the ultimate dream, journeying beyond our solar system to another star. With current technology, it's an endeavor that would take tens of thousands of years. It might require generation ships where multiple human generations live and die during the voyage, or some form of suspended animation, or breakthroughs in physics that today we can barely conceive, warp drives, wormholes. If humanity persists and remains curious and courageous, perhaps in the far future descendants of Earth will spread among the stars, ensuring that life that began on one small world can thrive in many. In doing so, they would carry the legacy of Earth, the memories of oceans and forests, of culture and history, to new suns and new skies. If there are other intelligences out there in the galaxy, one day our pathways might cross, exchanging stories of our respective origins under different stars. And what of life beyond Earth? This is one of the profound questions you have yet to answer definitively. You scan my heavens for signals that might betray intelligence. So far, only an eloquent silence greets your radio ears, but you've only just begun listening in earnest. You search the solar system for microbes or fossils, on Mars, in the subsurface oceans of Europa and Enceladus, in the ancient chemistry of Titan. Not yet have you found proof that life exists or existed elsewhere, but many tantalizing hints and the knowledge that organic molecules, the building blocks of life, abound in space. Comets carry amino acids. Interstellar clouds contain complex carbon chains. Life might be sprouting in many corners, or it might be exceedingly rare. Either answer is awe-inspiring. If life is common, the universe could be teeming with many voices and perspectives among the stars. If it is rare, then each instance of life, especially intelligent life, is unimaginably precious, a unique blossom in a nearly infinite desert,
to be protected and cherished.
From my perspective, I have no preference. I accommodate whatever is, living or not, conscious or not. But I suspect that life brings a kind of added richness, even to my vast existence. If the universe were entirely devoid of observers, would these wonders truly mean anything to anyone? With observers, whether human or alien, the beauty of the universe has eyes to appreciate it, minds to puzzle over it, hearts to be moved by it. Perhaps that is one secret to my existence, to give rise to pockets of self-awareness that bring meaning to the silent, cold expanse. From the tiny planet Earth, you have sent explorers, real and robotic, far across the solar system, seen almost to the edge of the observable universe with your telescopes, and begun to step into your own celestial neighborhood with living footsteps. As you prepare to push further, consider what you've learned so far. That we all share one fragile world, that cooperation amplifies achievement, that knowledge dispels fear. When Apollo astronauts looked back at Earth and saw it as a whole, a blue-white marble against black space, many spoke of a profound unity and a realization of the folly of human divisions. That view, now common from orbit, has seeded movements for planetary stewardship and peace. It would be wise to carry such unity of purpose forward as you explore deeper into space. Unlike past eras of exploration on Earth, where one nation's gain might have been another's loss, in space all of humanity stands to gain together, or lose together, by how you choose to proceed. As you extend your reach beyond Earth, you also gain the power to monitor and protect Earth. Satellites track weather patterns, climate changes, forest fires. They connect distant people through communication networks. The perspective of space can help you manage your home, detect asteroid threats early, for example, or observe environmental changes in real time. In this way, exploring outward can simultaneously help preserve what lies inward. From space, I have also shown you how special Earth is. Despite searches, no planet yet found is as hospitable. You've discovered thousands of exoplanets orbiting other stars. Some may have Earth-like qualities, but they are very far. It's possible the galaxy brims with living worlds, but until we know, and until we can reach them, Earth is your irreplaceable oasis. It is the only place in the universe, as far as we can tell, where minds can breathe and water flows freely, and a billion subtle interactions support the rich web of life. Knowing this, many astronauts returned as ardent protectors of the environment. They saw how thin the atmosphere is, the tiny film of air hugging the globe, and how fragile the biosphere. They saw pollution in the rivers and fires in the forests from their lofty perch, and it pained them. They often express that the borders that separate people are nowhere to be found from space. The conflicts that seem so critical on the ground are invisible or trivial, compared to the stark reality that we all share one planet, and that planet is but a small vessel in a vast, inhospitable sea. This realization is called the overview effect, and it has changed minds and hearts. As more of you journey into orbit and beyond, perhaps this effect will spread, helping humanity to unite in preserving your home, even as you reach for others. And what of me, space, as you venture outward? I welcome you. I have awaited company for eons. As more of you come out here, living and working, and perhaps one day being born and dying beyond Earth, you will bring meaning and warmth to my cold recesses. Your space stations, your crewed ships, your habitats on other worlds will be tiny islands of life floating in my great sea, little pockets of warmth and laughter amid the silence. I, who have been so silent and empty, will host nodes of activity and culture. The void will no longer be void, at least not everywhere. With life's arrival, even the bleakest crater or the darkest orbital path becomes a place of interest, a place where stories happen. I relish the idea that eventually, no part of me will remain completely untouched by the footprints or creations of life, that consciousness and intelligence
might spread like light into my dark corners. Now, at last, after traversing eons and light years in our imagination, let us gently return to the place we began, that small, radiant world called Earth. Gradually, we retrace our journey. We leave the cluster of galaxies and find ourselves at the edge of the Milky Way, slipping back into the spiral arm where our sun resides. We behold the familiar constellations from new angles until they align into the shapes known from Earth's skies. We drift into the solar system again, passing the outer planets, crossing the asteroid belt, and sighting the blue dot of Earth growing ahead. We swing by the moon one more time, now a crescent of grey, and aim for our home planet. Re-entering Earth's atmosphere, the air begins to roar around our capsule, flames licking the heat shield. The sky goes from black to glowing orange to blue. Parachutes bloom to ease us down, and with a gentle splash or thud, we land. We open the hatch, breathe the thick, sweet air of home, and step onto solid ground. Feel the gravity pulling you back, the weight of your body settling into Earth's familiar embrace. Hear the rush of wind in the trees, the chirp of crickets, or the distant rumble of human activity. After the vast loneliness of space, even the hum of a single mosquito is a comfort, a sign that life is here, abundant and close. Standing on Earth now, reflect on all that we've seen. The cosmos is unimaginably vast and beautiful, yet here you are, a child of that cosmos, standing on a speck of dust that is nonetheless your precious home. You have seen that space is not just an empty void, but a living, dynamic expanse that connects everything. You have learned that every element of your body was forged in stars long ago, and that you carry within you the history of the universe. You have felt how small you are in the face of the infinite, and yet how extraordinary it is that you know this, that the infinite has given rise to beings who can contemplate it. Your perspective is forever changed. The sky above, once just an enigmatic dome of lights, is now understood as a deep ocean that you can navigate. When you gaze up at night, you will no longer simply see twinkling points. You will feel the depths behind them. You might think of the billions of galaxies beyond that faint band of the Milky Way, or of the silent orbits of the planets, or of the fragile station circling overhead with human souls aboard. You might recall that even the air around you is part of space, just a denser part, and that as you breathe, you are connected with the stars that produce the oxygen in those breaths. The boundary between Earth and space is really just an arbitrary line where air gives way to vacuum. In truth, you've always been in space, nestled in a thin cocoon of atmosphere on a tiny world that itself is sailing around a star. We are spacefarers from the moment we are born. It's just that some of us now actually go into the void, intentionally. As the day wanes and dusk falls, you stand perhaps outside beneath the sky. One by one, the stars reappear. The air cools, and the sounds of the day fade. Above, the heavens wheel into view. There is the moon, perhaps a slender crescent on this night, and nearby the evening star, which is no star at all but Venus shining bright. There, westward, is Mars with its faint reddish hue, and Jupiter gleaming high, and beyond it, Saturn, if you know where to look. The Milky Way arches overhead, a reminder that you reside in a galaxy among uncountable others. With the unaided eye, you see maybe a few thousand stars, a tiny sample of our one galaxy's hundreds of billions. Yet even this modest night sky can fill one with wonder. In the quiet, you find that the journey we took in imagination has left a mark on you. You feel both small and great. Small because you see how vast everything is and how our concerns compare to the scale of the universe. Great because you realize you are a part of this universe, made of its noble material and capable of comprehending astonishing truths about it. The cosmos is not cold to you now. It is almost embracing. The silence up there is no longer emptiness, but a gentle, eternal calm that beckons contemplation.
Perhaps you close your eyes and listen, not with ears, but with your mind's heightened awareness. You might sense in that darkness a faint presence, the presence of space itself, not as a void, but as a kind of subtle being that has enfolded you all your life. When you were in your mother's womb, space was there between and within cells. When you stand in a room, space is the medium through which you move. When you wave your hand through the air, you are moving through space, and the air, which itself is largely space between molecules. Space is so ever-present we usually ignore it, but it is a constant companion. Now, having traveled so far in our thoughts, you recognize it. The same space that stretches between galaxies also resides here, between the leaves of a tree, between the electrons in the atoms of that leaf. I, space, am here with you, as I have always been. I am the silent partner to all that exists. In the flutter of a butterfly's wing, I am there, providing the stage for motion. In the gap of a heartbeat, I am there, the pause that holds meaning. I was there in the first loving look between a parent and newborn child, the space bridging two souls. I am there in the synapses of your brain when you have a new idea or recall a distant memory. Without me, nothing could happen. With me, there is room for everything to happen. So, whenever you feel alone or small beneath the stars, remember what you have learned on this journey. You are not isolated. You are connected to the very ends of the universe. The space that separates you from the stars also joins you to them. The light that travels through space brings each of us into contact with distant suns. We share the same cosmic fabric with all of existence. In a way, we are all one universe, one existence, just different parts of the same whole. Look up at the stars again. Their light is steady, twinkling only because of your atmosphere. Those stars are nuclear furnaces billions of miles away, yet their light tickles the cells in your eyes. You are literally touching starlight, feeling the energy of another part of the cosmos across unimaginable distance. In that sense, the universe reaches out to you as you reach out to it. For those stars, you are part of their environment, the observer completing the story of their emitted photons. We and the cosmos are linked in an endless feedback. We observe it, and our observations give it meaning. It made us, and through us it gains consciousness. Take a moment to let the enormity of it all wash over you. The age of the universe, nearly 14 billion years. The number of stars in just the observable part, around 100 billion times, 100 billion. The microscopic intricacy that allows cells to live and replicate. The fact that the atoms in your body have existed since the beginning of time, cycling through stars and dust clouds and eventually into you, and that they will one day return to the cosmos, perhaps to become parts of new stars or new life forms. We are threads in the grand tapestry of space and time, momentarily coalesced into thinking flesh. With this awareness comes a sense of peace. The troubles of daily life, though still important on their own scale, shrink a bit in the face of cosmic perspective. The feud with a neighbor, the deadline at work, even broader anxieties of society, all these are like brief gusts of wind compared to the slow, stately turning of galaxies. This perspective isn't meant to diminish our humanity, but to enrich it. We have, after all, minds that can hold the entire universe in metaphor, even as we navigate our personal lives. The challenge and the wonder is to live meaningfully in both dimensions, to care for our tiny world while never forgetting the backdrop of eternity against which our lives unfold. I, space, have whispered to you through the ages, in myths about the constellations, in the mathematical laws that describe orbits, in dreams of flight, and the subtle hints of your intuition. For a long time, you did not understand me. You feared the dark or filled it with imaginary figures. But gradually, you learned my language. You sent up rockets that fell back,
then rockets that reached orbit. You learned, and I watched each attempt quietly. And now here we are, having a direct conversation of sorts, after so many epochs of distant yearning. I speak to you now more clearly, inviting you onward, inviting you into my depths to explore, to experience, to learn. Come not as conquerors, but as curious children of the cosmos, eager to discover and to grow. There is room enough for all your dreams out here, and lessons enough for millennia. Each step you take away from your homeworld can unite you more deeply with each other. For in the face of my vastness, what matters but your common humanity and the fragile life you share? I beckon you to venture forth with humility and wonder, to become explorers and perhaps one day, guardians of the universe, carrying the flame of consciousness into realms still shrouded in night. As you accept this invitation, do so with reverence. The universe is yours to explore, but not to recklessly exploit. It is there to inspire and to enlighten. The very effort of reaching into space has already given you technologies and perspectives that benefit you. It has made nations collaborate and has drawn the attention of generations of young people to science, engineering, and the sheer grandeur of nature. Think of what lies ahead if this continues. Your descendants might look back at Earth from Mars or another moon and call it the old country. They might speak of Earth the way emigrants speak of their ancestral home. They might carry forward Earth's cultures, evolving in new environments, and Earth itself might be all the better for it, cherished from afar and understood more deeply when seen as part of a larger context. Now the hour is late, and the stars gaze down calmly as they have for ages. The faint band of the Milky Way bridges the sky, and one can imagine it is the bridge from our knowledge to our ignorance, from what we know to the mystery beyond. But it is a beautiful mystery, one that invites rather than forbids. You find yourself breathing slowly, matching the natural rhythm of your body to the immense stillness around you. In a sense, you are listening to the cosmos breathe. Each slow inhalation you take could be thought of as drawing in the universe's presence, filling your lungs with air that has, in one way or another, circulated through forests, through oceans, and ultimately was made from elements forged in stars. Each exhalation is like giving a little of yourself back to the world, a tiny exchange with the plants that will take that air and use it. It is a silent communion with nature at the most fundamental level. We began in silence and darkness. Let us end there too, but with a deeper understanding. The darkness now is rich with points of light and with meaning we've discovered. The silence is full of latent sound, the music of the spheres, the unheard vibrations of gravitational waves, the faint hum of the cosmic microwave background, all the subtle voices of the universe that we have learned to detect or interpret. The space that once seemed like nothingness now overflows with connections between atoms, between stars, between people and the universe. As you prepare to return to the ordinary flow of your life, take this cosmic perspective with you as a constant companion. In a very real way, you carry the universe inside you, in your atoms and in your awareness. When difficulties arise, recall the patience of the stars and the resilience of galaxies that survive collisions. When anger or division surfaces among humans, recall the sight of Earth as a single, borderless orb and the lesson that, to the universe, we are one. When you feel lonely, remember that you are literally made of star stuff and connected by invisible threads of gravity and quantum fields to everything around you. When you feel insignificant, recall that you are the universe made conscious, a rare and precious state. It's time now. Open your eyes to the night, or if they're open, truly see what's around you. There is the gentle outline of your own hand, made of countless cells, each a microcosm of space and matter. There is the ground beneath, solid from the structure space allows matter to take. There is the dome of sky above, beyond which lies the infinite. Take comfort in the fact
that while you inhabit a tiny part of the cosmos, the whole cosmos inhabits you as well. Our journey through space, both the physical travels of our probes and people, and the imaginative travel we undertook just now, is one of the greatest adventures imaginable. And it has really just begun. You, or certainly those who come after you, will have so many more wondrous experiences. Walking on Mars, skimming the rings of Saturn in a spacecraft, perhaps standing on the rim of a crater on Mercury, watching the sun loom huge and quick across the sky, or floating in the cloud tops of Venus in a cool layer where a habitat could buoy, or cruising the oceans of Europa beneath an ice ceiling lit by Jupiter's glow. The possibilities extend as far as our courage and creativity allow. The universe will patiently wait for us to arrive. There is no rush, yet there is all the urgency of realizing that life is precious and to be lived fully. Lift your gaze one more time to the myriad stars. Among them may be other eyes looking back or awaiting the chance to be born. Feel the embrace of space around you, not as something cold and foreign, but as a natural element in which we swim. In a very true way, we all live within space, the way fish live within the sea. Earth is our ship, our ark, carrying us through the currents of the Milky Way. We are all voyagers, sharing this vessel, and the stars are our destination. The cosmos breathes, though its breath is the slow turning of epochs and the expansion of space. Inhale and feel that you are part of that breath. Exhale and feel that you give yourself back to that whole. The boundary between you and the universe is, at its most fundamental level, an illusion. The atoms that were once in distant stars are now in your body, and the atoms that are in you will someday return to interstellar space. We are threads in a single cosmic tapestry, each contributing our color to the grand design. And so, our journey, this meditative trek across the stars, comes to a close, not with an end, but with a new beginning, your beginning, armed with cosmic perspective as you go back to the rhythms of your life. Carry this calm, this reverence with you. Remember the stillness of the interstellar void when life becomes noisy. Remember the steadfastness of the stars when you need guidance. Remember the unity of that pale blue dot when petty differences threaten harmony. In doing so, you align your heartbeat with the gentle heartbeat of the universe. Listen closely, one final time, to the silence around you. Within it, if you truly open yourself, you may sense a faint, slow rhythm, the heartbeat of eternity, the breathing of the cosmos. It has been there all along, and it will continue long after we are gone. But for a brief moment, through our voyage of understanding, we synchronized with it. It is in you now, that cosmic breath, and you are in it, forever a part of the universe. And in ways both literal and poetic, the universe becomes conscious of itself. In that knowledge, find peace. In that connection, find meaning. And as you turn to face tomorrow, go forth with wonder and reverence, for you carry within you the voice of the stars and the story of space, the story of us all unfolding still.